I made a shocking discovery today when I was hanging out over at MEUK's Discord server.
Are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, did you hear what I said? It's all about...
No, he's not in here now, but do I have you to thank for Zanick being here?
Oh, no, you don't. But I was going to give him an invite eventually. So I may as well take the blame, but it wasn't me.
That's what they all say.
In a while since we've talked about uphill rivers.
Yeah, I'm not so sure Zanick will want to come and have a chat while we're in
Emma,
here.
do you want to go live?
By the way, Emma.
Do I?
Maybe.
Mobius is still having trouble.
Yeah.
Oh. Maybe is there an update or something?
There's got to be a bug or something.
Yeah, he said he tried on 24/7 to see if it worked, and he was able to hear there. He's managed to join, but he can't hear or speak here.
Yeah, I've changed server locations, and that's not made any difference.
Yeah,
so
Discord's been doing that sort of thing recently.
It's either a bug his end or just a Discord blip, unfortunately.
Yeah, I think I'm
kick
gonna
him and re-invite him.
I'm gonna have to have a reset on mine as well.
Yeah, I had an update earlier. Another one. Yeah. Pumping out the updates quite frequently.
Yeah, another one.
Oh.
I don't think I've got one.
Yeah, I had one this morning, and I think I had another one yesterday or the day before.
I put a tweet from Ferrock in debate discussion, and this is there's quite a lot of these things coming on. It's like optics, they're a big thing at the minute, right? Especially looking at sunsets or whatever, things disappearing in the distance. Ranty was having that one the other day, and like this one shows.
Oh, man.
It's like it's as though the sun never actually, goes down. Is that what you're saying? Drop? Chike, was that what you were using?
You use them all.
Yeah.
Drop, tilt, slope.
Yeah, hump. I think I heard. Yeah.
Yeah, all of them. You used them all. So take your pick, Bev.
We got them all, he said.
Yeah.
It's good. That isn't it?
Yeah, that's it. Yeah, there's loads of those sort of things coming out at the minute where it just seems to go away in the distance. It doesn't seem to actually.
Well, it does change in size as well.
Yeah.
Which you can't see because of the glare generally with your own eyes. It's only when you zoom in with these P1000s or P900s or these high zoom cameras that you get to see that. Otherwise, it just looks like.
Oh dear. Zanick's already commenting on it, so.
Oh, God.
It's sort of out of focus or something. It doesn't really matter, really, does it? Because you're just looking at it, and it would seem to be, or what you'd say, over the hump, curve, tilt, slash, slope thing. But I'm guessing that's why it's such a problem with us when we say the water level's horizontal. Because if we prove, and not that it really needs proving, because I'd say it's already been proved that the water level is horizontal, then it can't actually disappear into the water, can it?
Yet it does in your picture in your
just
video.
Gets further away, like that screw doesn't disappear in the screw in Spot-On's loft doesn't disappear into the floor.
It does. It exactly does that. If you took that video and you waited for
Zanick.
the sun to go down by the sunset, you would see it disappear and zoom in and zoom out like you did. The problem is you got a blurry sun. You got a blurry sun. You got crappy video. Get a good video, then you'll see what's
I'm gonna
going
kick
on.
him out.
It's just something we see on Twitter.
He's just in here for 30 seconds. He's gonna get kicked. Zanick, don't you get tired of talking out of both sides of your mouth?
Freaking blowhole.
Yeah, so that's a different video, right? That's just one we got from Twitter that somebody had took a picture. It just says
just a little video, you know, that someone's put out there. It's not there for, you know, like everyone to descend on and tell them how bad it is, because probably that wasn't his intention.
yeah, it's just
What do they do?
Like the tweet says, what the eyes can't see, modern optics do. Sunsets are an optical illusion. That has been exposed by these cameras. These cameras can show you that it's just an optical effect.
Operator error. I have a sunset that you can now compare with objects around the sunset. Buildings we know that are there. And lo and behold, half the sun is gone. See, you have to get a clear picture of that.
It's an optical effect,
what you don't
right?
realize is that all your pictures and videos that you seem to use to back your statements.
No, I was just showing people, Zanick. You're just going, have a look at this.
Zanick, your rumpusing isn't gonna last long here, just so you know.
Yeah.
I'm sure if you can have just a conversation without yelling, you'll do way better.
Okay. So Bev, so I got a picture there. It shows buildings that are an angular size that could be measured and a sun behind it, yet the sun is half gone. Now, if you zoom in with any optics you won't see the effect that you think you claim to see.
When you say...
Can I just say that the sun actually looks quite squashed, doesn't it?
There is some distortion, I will agree, but that's not the point.
Okay, so what's happening there then?
You're obfuscating. Don't obfuscate the point. The point is, you see the picture, the sun is half hidden on the bottom and it's due to the horizon. Nothing else.
Okay. Can I show you another one that my son took? I think it's sped up, this one.
Chike's put one out.
Yeah, proper one by Wolfie.
There you go.
I think he's promoting your video there. I'm not sure.
Did you say your priest, Chike? Did you say a proper one from your priest, your high priest?
No, I said the proper one from Wolfie. And I think
your high priest. I get it.
He promotes the video you posted before.
So there you go. What do you reckon to my one? Oh, my lad's one, sorry.
All right, so I gave you a few that are pretty much indisputable, especially the last one where the sun is about 1/4 of the sun is being shown there. And you can see a very straight line, horizontal line, if I dare, of the ocean. And the sun is 1/4 showing. Now, if you zoomed into the heart's content, you would not bring that sun back in its full glory.
Do you?
Also, a multiple picture.
Yeah, but it may be an effect.
No
An
effect.
optical effect though.
There's no
Sorry?
effect. There's no
Do
effect.
optical effects happen whilst looking at the sun?
Not
Optical
this
effect.
effect. This is not showing any effect.
Oh,
It's clear enough to show there's no effect.
How do you know there's no effect?
Because you can see 1/4 of the sun and a straight, distinct line of the horizon.
Is there a video to go with that?
Straight, did you say?
No. Straight and level and flat. Every word you want to use. Sure.
Okay.
Oh, it's straight.
It's straight, yeah. That's job
Relatively
done.
Straight.
Cheers. Well
Relatively
done.
straight. Straight in that frame. With
And
a
what's
few-
the distance from right to left? And what's the observer's height?
What does it matter?
Does it not matter?
Well, that can't
No.
be horizontal if you're at high elevation.
Yeah, it's still
you see
be
it drop
horizontal.
from left to right.
Relatively horizontal.
Can you ever see?
We're talking about
Hold on,
30, we're talking
Zanick.
about 30
Hold
arc
on, Zanick.
radians. We're
Don't
talking
come in
about
here and
30
start doing this.
We're talking about
Seriously.
30 arc radians. Of
Zanick.
curvature. Very,
Right,
very
stop talking over.
You understand the difference between a curve around you and the curve away from you?
It's all the
There's a
same.
difference, you know?
It's all the same on a
not
sphere.
that one.
No, it's not the same. It's very
Yeah, it
greatly
is.
different.
It is. It's all the
greatly
same on a
different.
sphere, Zanick.
It's greatly. You're not listening to the words I'm saying. So the difference between the arc around you is that it is always going to be like a hula hoop, as I've mentioned many times, below your eye line.
Is that
low level?
seriously? Is that where the hula hoop came from?
Hold
Have
on.
you been
Hold on.
teaching people the hula hoop?
Hold on, you're interrupting me. So, but the curve away from you will only be shown by what is missing with respect to the horizon and how far it is dropped below your eye level based on your elevation.
Zanick, please.
So you gotta talk.
Yeah, no, yeah, I have, because when we talk here, we try and talk where things make sense. And what you're talking now is you're just stringing a load of words together that mean nothing. I mean,
to you,
you've just said it is a straight line, flat, level, horizontal, whatever you want, is what you said.
I was playing with you, Bev, because you like the words.
Well, why are you doing that if that's not what you mean?
funny.
That's double talking, Zanick. We don't do that here. So, can you talk and mean what you say, please?
I always did, and I giggled and laughed as I said it because it was funny. Don't take it too seriously.
It was
Relax.
it was an awful joke.
Oh, I know it's very sensitive to you. This
It's
topic.
not. No, Zanick.
It's just a shit joke.
So the horizon is going to be slightly curved around you, so much so that you can't detect it beyond human perception. Why? Because it is a circle that is around you.
Have you got any proof of that, Zanick? Any
That's
at
basic
all?
mathematics.
Basic mathematics, right? Yeah. So, what would you say mathematics is? Horizontal? Is that a mathematical term?
Yes.
Yeah. So if I look up horizontal, and it says parallel to the horizon, would that mean like a mathematical term?
No, it means
it's parallel. Is parallel a mathematical term?
No, it means you use a dictionary to
No.
try to determine
Actually,
what a mathematical.
Actually, Zanick, when
I'm
we did our
talking-
geometry the other day.
I'm saying you used a dictionary.
No.
To find the definition of a mathematical term.
No, Zanick, if you let me finish without interrupting, we went over this the other day when we did our geometry 101. The definition for parallel is number 35 in book 1 of the Elements, the Euclidean geometry book. So it's not defined in a dictionary, it is defined within the definitions of Euclidean geometry. That's mathematics. That's where parallel is defined. Do you want me to read it, or do you understand what parallel means?
I know what parallel means.
Okay, right. So when it says horizontal is parallel to the horizon, do you understand what that makes the horizon?
No, that's
it makes it parallel to horizontal, which is a straight line. It cannot be curved.
Yes, it can be curved. You just don't understand the definition well enough. You're saying A equals B, B equals C, therefore A equals C. And that usually works, but in this case,
what doesn't he understand? What is he missing? Why don't you explain what he's missing?
He's missing the point that you talk about. He's mixing Euclidean and non-Euclidean geometry is number one.
No, he's talking horizontal. He didn't bring up.
Hold on. In a two-dimensional, have a straight line that actually falls like a bullet. It can be shot straight, but it will fall. It'll have a curve in it.
That's
but
not straight. How does it have a curve in it if it's straight?
Good question. Now I want you to shut.
No, it's not a good question. It's a contradiction. You contradicted
yourself.
No,
it's not.
Okay. Before you go on, hold on. Stop right there. Stop. Wait, you gotta stop. Zanick.
My turn.
Zanick, stop.
I'm responding. It's my turn to respond.
No, but we're going over things. Zanick, no, I asked you something.
Question. I'm going to respond.
I'm asking you to please stop talking.
I'm not going to stop doing this.
I'm asking you to please stop talking.
Guys, seriously.
Stop talking.
Stop.
Respond.
No, both stop. Zanick.
He asked me a question.
Yeah, Zanick.
Whoa.
Zanick, calm down.
We don't do that around here.
You can be
Seriously,
calm, bro.
Yeah,
We're not attacking you.
I've just muted you for a second. We kind of do things here differently, Zanick. We try and have a conversation, so that means a little bit of give and take, two-way conversation. And there's a few people in the room, so, just slow it down a little bit. I'll unmute you, but literally, you don't need to be here. So don't take the piss.
Yeah, here's the point. Before you go crazy, Zanick, let me make my point so you can address it. I'm asking it now. Hang on. No, let me finish, please.
You already did finish.
No, but I'm not. If you will just stop for a second. Zanick, I would like to clarify so you don't go off on a tangent. Okay, now we're talking straight and curved. Are straight and curved synonyms or are they antonyms?
They can be mutually exclusive.
I didn't ask if they. Okay, can you draw a line and show me something that is
Let
straight?
me finish and I'll tell you. 5 minutes ago, I have the answer for you.
What I'm trying to do is but let me finish.
You don't need to.
I'm not going
to. I can answer right now.
Bro, come on.
I can answer right now.
No, but you don't know what I'm talking about. You're answering what's in.
Why don't you yield for a second? Let me finish.
Go.
Okay. So if you shoot a straight line in 2 dimensions, left and right, it'll be perfectly straight. Straight as an arrow, but it will have a curvature as it falls. So there's an example of a straight shot or a straight line in 2 dimensions, but in the 3rd dimension, it has a curve. That's my answer.
Zanick.
Okay, so hang on. You are using contradictory terms. Now, what you're doing first, you're drawing a line. Okay, now, if we're going to draw a line, a straight line, right? When you say straight, that means the shortest distance between 2 points with no deviation. Now, a curve is deviation. So when you use the term straight and curve to describe the same thing, you are using a contradiction that cannot work. It cannot be possible.
One of the reasons that you probably didn't pass 5th grade math is that you don't understand the difference between 2 dimensions and 3 dimensions.
Yeah, that's not how we do things either, Zanick.
Okay. So let me explain.
So what I'm talking about is 2 dimensions. So if I have a Cartesian plane and I have 2 points or 1 point in the distance that I want to go to, and you said the shortest difference between myself and that point would be a straight line. Now that is true, but I can have an arc that goes to that point.
That arc's not a straight line. That arc is not a straight line.
You're already.
Is that arc a straight line?
You're already completing my sentence before I'm finished, James.
Well, because I know. So is that arc a straight line?
Left and right, it is.
Okay, so an arc is curved, so it's not a straight line.
It is staying straight because it is not deviated left and right.
Okay, no.
What?
Hang on, listen. No.
Can I finish?
No, I got to interrupt you. I got to interrupt you. In 3D space.
Everybody. Let me finish. In Z-axis, I have a deviation. That's all I'm going to say.
Okay, so if you have a deviation, if you have a deviation, listen to these words.
Oh my God. Go ahead.
Zanick, if you have a deviation, you don't have a straight line. Now, in 3D space, I'm not done. In 3D space, you have X, Y, Z. Now, if you have something that is going straight on 2 of those, but then going down, it's not a straight line. Do you understand that?
In a 2D reference.
No, I'm talking 3-dimensionals. We're talking 3-dimensionals. If
you
have a deviation,
see, that's why clarification is everything.
And this is why you're not listening. So in 3
I
dimensions.
am listening.
But listen to me. You're talking now. So we're in 3 dimensions. We're in 3 dimensions. Now we're going to take a point where I am and a point off in the distance in 3 dimensions. Now, if I was to connect those with a straight line, there would be no curve, no deviation whatsoever. Now, this is in 3 dimensions. Now,
Correct.
if you start
Correct.
if you start deviating at all, it is no longer straight.
In 3 dimensions, you're right.
Yes. So now, a geodesic, is it a straight line or a curved line?
Are you finished?
Can you answer, please?
What's the question?
Is a geodesic a straight line or a curved line?
A geodesic implies a 3-dimensional shape.
No, a geodesic is okay. The line that follows the geodesic, is that straight or curved?
It's curved.
Okay. So you're following the surface of the Earth is not a straight line. So you don't have a horizontal when you go. You're horizontal, or you're horizontal.
Horizontal is not curved.
Yeah. Okay. Exactly.
Brilliant.
So your horizontal cannot curve. So do you see now how this water level, which is a horizontal that does not curve, do you get where this is going now?
No, I didn't say the horizontal was a water line. You said that.
No. I said horizontal doesn't curve.
Horizontal does
Straight
not
lines
curve.
don't curve. And straight lines don't curve,
straight
right?
lines don't curve. I'm in a 3D space.
Yeah, okay.
You're right. So what's your point?
So great. There we go. So now we have established that in 3D space, straight lines do not curve.
Correct.
And we
So
do live in 3D space, right?
In a 3D space, if I went off in a straight line, the Earth would curve beneath me, and that's why we have the horizontal line differentiating between where it goes and where the horizon is based on level.
What's the horizontal line in your model?
A tangent to the circle.
No. What do you use to establish it?
A level.
What kind of level?
A bubble level, a water level.
So water, but that water is curved in your model.
A level is perpendicular to plumb.
No, we're talking horizontal.
Don't talk over it. You are too quick to talk over it.
Listen. No. Now you're going.
This is on you, right, man. This is on you.
I'll let
keep on
you go.
doing it. Stop doing it. It's on you. You keep on interrupting me. Don't let me. You're making me speak quickly and talk over you. Don't do it.
Okay, so you switched from horizontal to level. I'm saying.
No.
We have let me finish. What did you use in your ball Earth model where water is curved? What did you use to establish a horizontal, not a level? I don't care about your level because your level is curved. I want to know what you used to. Hang on, I'm not done. Zanick, you're talking over me. Let me finish. I'm asking you, what did you use? What machine or mechanism or thing did you use to establish the horizontal so that you can see deviation from that?
The level means, and this is where you're confused, an orientation perpendicular to plumb. And you can use anything that can develop a 90-degree angle. If you can
I'm not asking about level. I know, but you're talking about level. I'm not talking about level.
I'm in the middle of a sentence. This is your problem.
But you're talking about level.
No one else
would
talking
about horizontal.
You. Stop it. So listen.
Okay, are you going to
develop level, which is a straight line?
It's not about level.
Orientation. Stop it. Perpendicular.
It's about horizontal.
That is a straight line into
it's
the.
It's about horizontal. Can you say it's a? But you tell me.
Yeah. Can we just stop this? Right the hand. Just a minute. Right. Just a minute.
Horizontal, which is
Can we get a bit of control over this at the minute because we all know that Zanick isn't going to take anything, and you're trying to get him to say something. Right the hand.
So bad. I made it very clear. He doesn't understand the difference between what level is.
Well, don't say he doesn't understand. Please don't say that.
Horizontal. I never used the word level.
Okay.
I said, what did you use to establish horizontal? And then you switched to level.
What do you mean by horizontal? Let's establish that first.
Can I have 7 seconds to just finish without him interrupting me, please? So if we have a horizontal, which is established by a level, which is perpendicular to plumb, that will be a straight line into the distance. I think we all would agree. The difference is the surface. Hold on. I'm almost done. The surface that we are traveling over is not horizontal. It is curved. And we know this because in the end, at any point, we can establish a distance, a divergence that is greater than when you unoriented that particular straight line. Does that make sense?
Well, yeah.
Now, what did you use to establish that straight line?
I already told you.
You said a level. What kind of level? You're going to
Any
say water.
Level,
water
level.
curve.
A
bubble level uses water. Okay, so
What?
are you
It
saying
uses
are you
spirit.
saying
It doesn't use water. Okay.
A spirit
you
level.
use a spirit level to establish a horizontal?
Yes.
Yeah. We've got all of the pictures. We've already been through all of this right to hand with Zanick many times before. Zanick has rivers that flow uphill.
No, you're the blue.
Right. He has the LIGO device is the most levelest, straight. No, sorry, not levelest. The straightest thing in the universe. But
Black.
if you put a ball on each end of it, they will roll to the middle.
Correct.
Correct. Yeah. And if you put a level or you drop plumb bobs, what happens to the plumb bobs at the ends?
They're not level. They're not parallel. They are inward. They point inward.
They point inward. So when you drop a plumb bob at one end of it, it points towards
towards the center.
Yeah, at both ends, right?
At both ends.
Yeah.
Yes.
Observably so, right?
Observably so. Yes.
Right. Okay. So, but it is the straightest thing in the universe as well, and balls roll to the center on it.
Right, and this is where right hand doesn't quite understand.
No, this is where everybody now knows that you will say anything, Zanick.
No.
Because it just doesn't make any sense. Don't say no, Zanick.
Hold on, Bev. You understand. Right hand does not. But you can say, I understand, Zanick, but you are high or this doesn't happen. You could doubt this is actually an actual situation. Now, right hand doesn't even understand what you're saying. That's the difference.
Yeah, he
So
does.
you are telling us verticals are two V's, right? A V because they dip into the center. So that's your vertical is a V, and then your horizontal is a frowny face. This curve that goes through the V's. Bro, yes, that's your model.
No, he doesn't. No. Right the hand, it
Right
doesn't.
hand doesn't understand. No, the straight line is straight. The straightest object in the universe within 20 thousandths of an inch over 2 miles. I worked there. I was in the building many times and talked with engineers about it. And we did the demonstrations. So it's all, the joke's on you. You don't understand. So the end lines that are discernibly and observably inward. Now you could say, like Bev did, that's BS. I don't believe it. Hold on. I'm still talking.
Yeah. Let him finish. This is some good shit, this.
See, Bev, hold on. Bev, let me, please. Bev understands. Bev knows that he thinks it's BS because he doesn't believe it, but he understands it. You just said a sentence that showed me you don't understand it. That's one. It's a whole
I'm drawing you a picture. Bev, wait till you see this picture.
I've already got a picture that Zanick drew for us. I mean, I don't know whether he drew it, but he said he did. We got the water level one. Can you remember that, Zanick? Is this your writing? That one there with the water level, the 8 inches.
To be fair, I just wanted to let Zanick know that I was here listening to his words. I didn't want you to miss, Zanick, that I was here watching.
Thanks.
All right, thanks.
Yeah, appreciate it.
Good luck, sir.
All right, I'm posting it in the general.
The
plumb line
the difference
dip
is
into the
Bev
middle.
understands it, doesn't believe it, but right hand doesn't understand it, and that's the
Oh,
difference.
Zanick,
so there are your
please.
plumb lines going into the middle, right? And then the horizontal is going to be a curved line.
No,
where did you put it?
You just showed it again. You don't
Into the
understand
general.
it. You don't understand it. Even Racky understands.
Bro, you think plumb lines converge into the center of the Earth?
They do.
So that makes a V. So if you have, let me finish. 2 plumb lines a mile apart make a V, and then your horizontal, which follows the Earth, makes a curved line. So what I just drew is how. This is how. Yes, exactly. Yes, you keep saying no, but this is your model.
That's the point of it.
Dude,
But you keep saying no.
Where is this
Bev
picture,
understands,
please?
You don't. It's straight as an arrow. The line.
We
straight,
don't have a general.
10,000 of an inch
Right the
Over
hand.
2 miles.
Straight.
Also,
hang on.
2 seconds. Just I think I've heard Zanick say before that because there's some like the ground drops away from the end of the LIGO. That's also
live stream text.
Is that right, Zanick?
Well, it's in the mountains, so you can't really use the surface as a reference.
Oh, okay. I thought you did once. You said because it was out of the ground one end, and that showed like that there was obviously some sort of drop there.
No, I think that might have been Fight the Flat Earth. That
would be a drop.
He did say it. I remember him saying it.
I think the Fight the Flat Earth said that.
Danny, you're
Oh, is
crazy.
it?
Yeah.
Over water or something that was actually level, that would happen. Yeah, so it'd be a divergence distance
So
walk.
there's no 90-degree angles in the baller. You
Yeah,
can't make a 90.
right in the center. Right
Yeah,
in the
it's
center, there's a
perpendicular,
little-
isn't it?
Yeah,
Well,
right in the center.
your
Right in the
horizontal
center, it is level.
curves.
Right in the center, it is level. Right in the center, it is level. Everywhere else, it's not level. That's the point
I'm
of
not
all
talking
this.
about level, bro.
90 degrees is level, and it's a straight object.
No, 90 degrees needs two straight lines.
Yes.
You don't have two.
Yes, we do. The plumb line and the object.
Your plumb line is veering into the
No,
what's it
it's
called?
straight as an arrow, right in the middle of
No,
it.
but hang on. No, listen.
You don't get it still?
Zanick,
You're
listen.
gonna laugh when you put this
Zanick,
back.
you're
Seriously,
just
anybody
stop.
listening is gonna laugh. You're
Okay.
right to hand. You've lost. Don't even try to argue it. It's
Okay,
ridiculous.
I know. Okay, so that's why you overtalk me. So picture we have a plus sign, right? Now they're both perpendicular. You have 90s. Now if you only take the vertical line and move it left or right, like only move the bottom, so the top stays and the bottom moves towards the center of the earth, you don't have 90-degree angles anymore. You've now made one obtuse, two obtuse, and two acute.
No,
So that is not a quote.
You can't do an angle to a
Right.
curve.
That's
We did
exactly
that
what
the
you
other
have.
day.
So
Okay, so then you don't have 90s. You don't have
yes,
90s
there's
in your
there's
model.
only 190 in the whole structure. Only one. Like you said, the plus sign.
No,
And then if
you
go to
don't
the-
have no.
Let me
Your plus
finish.
sign.
Right to
It's
hand, you
not a
can't
plus
control
sign.
yourself. Listen, before I freaking wrap you in a noogie.
You're projecting
Stop it.
that you
Stop
can't
it.
control yourself.
Stop it. You have the plus sign in the middle. And as you go outward on this 2-mile structure, a mile left and a mile right, the ends of that will have plumb lines that are angled inward. The object itself is-
Zanick.
Hold on. I'm almost done.
Yeah,
done.
yeah, but you're talking
Object-
rubbish.
He doesn't understand. Let me
Yeah,
finish
no,
talking right
Zanick, we don't do this here.
now. I'm talking to him.
Yeah, but you're talking rubbish.
No, let me
Yes, you
finish my
are.
thought
You're
before
talking
rubbish.
absolute
I've done a long time ago.
bullshit.
Stop doing it.
You're just making stuff up. Everybody knows it.
Bev, he's taking the Earth's curvature into consideration with the vertical.
It's like I can't stand hearing this bullshit.
I've just muted him. I've
Yeah.
just muted him.
And right the hand as well. You're arguing with somebody who won't ever get it. He doesn't understand. He will sit there and tell you that over that straightest thing, you can put a ball at each end and they will roll to the centre. I mean, look at it. It's an L-shaped thing. What's he talking about?
He is only here to cause disruption. He is not here to have conversation.
Yeah.
So as long as all he does is we give him we've given him 10 minutes, 15 minutes, and all he's done.
He's already had 2 strikes, so
Yeah.
I was just waiting for a third.
Yeah. So all he's done.
You would
over the
just. You
last
hope they
15
address.
minutes
If you
is
dip
cause
your
disruption.
vertical, if you dip your vertical into the center, you lose your 90s. I drew it like if it's moving, if your vertical is anything off, if it's going towards the center, there goes your 90.
Yeah, well,
Can't do it.
we did this yesterday. We did a whole 2.5 hours explaining that if you want an angle, you need 2 straight lines. You can't put a curved line there.
That's math. This is math. This is why math is so empirical, because the connection between 2 points is always the same. If you start moving it on a deviation, you're going to get skewed results. This is math. This is the entire idea behind math, whatever it is that you have standardized things that never change. 1 is 1. That's why 1 + 1 = 2. 90-degree angles must be made with 2 straight lines, not one that is deviating towards the center of something. We need to rebrand school.
I'm going to have to stop you there because 1 + 1 is 2 is because somebody's told you that 1 + 1 is 2.
Yeah,
you can't explain that. Now,
1 represents a unit in a reality. You know what I mean? It's the idea that you have an apple. So, and
but geometry is different, right? Right, the hand. Geometry is different. You can prove that a straight line has to be a straight line through geometry, right? In order to do all of the angles and everything has to be proved and can be proved.
Yep. Because if you had an actual sphere, right, in order to get the radius or the diameter, you could not curve the line. If you curve your radius line, it is not the actual radius anymore.
Curve your radius? What the hell are you talking about?
It's a straight line,
So, like,
right, Jake?
when you, yeah, but on their,
It's a
on,
guaranteed
not in their model,
straight line.
That's what you said.
Yeah? Jake?
Who's talking about curving the radius?
Yeah, we're talking about
nonsense
straight
is
lines and curved lines. Now,
Sure.
you will give us a guarantee that a straight line, a radius, has to be a straight line. Right? Jake?
Waiting. By
Yeah.
its definition, it's a line.
A straight line. That with no curvature. Right? Now, your vertical that you imagine on your model is an extension of that radius.
Mm-hmm.
Yes. Definitely?
Yes.
Okay. Now, what you imagine as perpendicular to vertical is horizontal. True?
Yes.
And that perpendicular means the relationship of one straight line to another.
We're good so far.
Okay, so, and that means, because it's a perpendicular means right angles, that's an angle that is measured between two straight lines.
Okay.
Yep, you're okay with that as two as well?
Yeah. Why did we curve the radius?
Why did you curve the radius?
No, where? When?
I don't
How?
know. You like we're
Who
just
says
we're just
we curved the
establishing.
radius? I don't-
We're
this
established.
guy is talking about curved radius.
He said, yeah. You said he said you can't curve the radius. Did you hear him? It was nice because it gave us a chance to work out this straight line.
No, who's trying to curve?
No, Zanick was trying to curve the horizontal. Did you not notice?
That's fine.
Sorry?
not. That's when you start getting
He
wrong
wasn't
lines.
trying to curve the horizontal. Only Earth, surface of the Earth.
That's the horizontal that you imagine, right?
No,
It's
that's your
perpendicular.
plane.
It's perpendicular
It's your plane.
to vertical, isn't
No.
it?
No.
No, it's amazing how fast you just do a flip-flop from saying that it is, and then
Right,
now
it was
it's
with you,
not.
and then gone.
Yeah.
You were like, yes, 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 no.
Horizontal. Horizontal is perpendicular to vertical at that point, and that point only.
But they are a straight line. So it can't just be at that point, because they are two
Yes, it
straight lines.
can.
And straight lines...
Straight lines only intersect at one point.
No, lines in math or lines how we use them are infinite. You always use an infinite line when you're you know, and that's a line. So if you're not using an infinite line, you're using what's called a line segment. This is why we have very
Okay.
different terms in math.
Okay, so what you're trying to say?
Well,
If it's a line, it will continue, and you can't have a local line that goes off into infinity that is straight, but then when it goes off into infinity, curves under you.
Can we
You're just
can we just go
following
over
the
the
same
postulates, please, for Euclidean geometry? Because that's the geometry
not
we're
the same
using.
line.
Is that the geometry we're using here now, Jake? Euclidean
You're
geometry.
using line segments. You'd be using line segments, Chikey, not lines. This doesn't say that a straight line segment may
You
be drawn.
want perpendicular.
It
to
says,
vertical.
actually, the postulate number 2 says that a terminated straight line may be produced to any length in a straight line. So that does away with your little point thing. It means that the perpendicular, that the two lines that perpendicular was referring to, can be produced to any length. in a straight line. Right, so if vertical and horizontal are perpendicular, then that two straight lines can be produced to any length. It's a massive problem, I know, because you've not really looked into the geometry on how geometry actually works, the rules that are set down.
Yeah, that's why parallel lines can't intersect ever. Just not when you see them here locally. That means if you keep these lines, that no matter how long or you make them and draw them, they will always remain parallel, right? They will never start touching. That's what we work on.
Are you sure about it?
That's the postulates that is what the foundation of logical thinking that math is built upon.
Okay, so try to make two parallel lines, north to south, and we'll see if they intersect or not.
The parallel. If they intersect, they're not parallel. What's so hard for you to understand? A parallel line. Do you want me to get you the definition of a parallel?
You make them parallel. You will measure them to be parallel, and all you have to do is keep going straight.
Can I ask a question here to Chaiki?
Since your Earth
let me ask
is
you a
not
question.
core.
Chaiki, let me ask you a question.
No, I
let me
didn't
ask you a
finish.
question.
No,
when these parallel lines,
when I'm finished, you can ask. Continue to walk on your flat Earth towards north, and see if those parallel lines are really parallel. And if not, you must assume you haven't walked on a flat surface. Otherwise, they would never intersect.
Okay, Chaiki, do parallel lines, when they appear to converge, do they have any magnitude upon appearing to converge?
What does it even mean?
So in geometry, a magnitude is a length or a solid, some type of measurement. So when apparent lines converge, do they have anything measurable, anything solid there?
What do you mean?
Very simple question.
No, I don't understand what you're asking.
When you have parallel lines apparently converging, is there any magnitude to the convergence?
I really don't understand.
Are they getting closer? Are they getting closer in the distance? I think is what he's trying. Is there a measurable change in how?
No, he said they are parallel. No.
Okay, so if they're parallel, at what point? If they're parallel, at what point do they converge to make your ball?
Never.
Welcome to Flat Earth. Thank you.
No. Start to walk on two parallel lines.
Okay, listen to yourself.
And tell me they did not intersect.
Oh my
then
God.
welcome me to Flat Earth.
You are a
Don't assume they will not intersect.
You just told us they don't.
You just told us.
No, I told you parallel lines.
He's been learning from Zanick, right? Zanick feeding you.
I'm telling you, two parallel lines, walk straight on them toward north, and tell me, or any direction that you want, and tell me they did not intersect.
Right.
Then you can welcome me.
Can you just give me your understanding of north, please?
I corrected myself. I said any direction.
Yeah, but you did say north.
Any direction.
Right, so if you're heading in any direction, are you using a compass?
No, you're using the straight line. You keep your
right, and
straight on
okay, so
line.
like what we do then, right? If we're doing that, in order to keep with the, what's it say? Parallel straight lines are such as are in the same plane, and which being produced ever so far both ways do not meet. So we could walk together with like a stick in between us, keeping us a meter apart, and we could all walk in any line we wanted to, and then we would never meet.
Not allowed.
What do you mean not allowed? That is the definition.
Why are you interrupting?
No,
let him speak. Let him speak. Stop saying no. Stop saying no and let him speak. Stop letting him stop talking and let him speak.
Just let him go,
what you're
Data.
looking for. Look, if you're going to check that the lines are indeed parallel, you can't use a measurement to keep them parallel forever. No,
definition,
you need to keep...
Jake, by definition, a parallel line. I'll read it again. Parallel straight lines are such as are in the same plane and which being produced ever so far both ways do not meet. Right, now that is the definition of a parallel line.
So, and now when we're going to are indeed parallel, we can't measure the distance between them to do so, because that's the definition of parallel.
Yeah.
Now we want to test whether they are parallel.
No, the definition. It's like you can't say, here's the definition of a straight line. Now we need to test whether it is a straight line or not. That's not how things work.
We're not testing whether they are straight
What
lines.
are you testing
We're
then?
testing whether they are parallel.
Which lines are you talking about?
You don't test the definition, Jake.
No, I'm not. Yes, I'm testing the definition.
What? This is not. This is like. Do you understand that you're testing a thought experiment that people have thought up?
This is Euclidean geometry, right? It's lasted for thousands of years, and now Jake decides to go. I'm not so sure about that. Seriously?
Parallel lines.
No, you don't understand.
Yeah, and we just have to check that parallel lines are actually parallel.
You claim.
I've just read a definition.
Okay, so now we're going to move in two parallel straight lines. Yes, we'll measure them to be parallel to one point, and we'll keep going straight on each of them, regardless of the distance between them. All we need to do is make sure every point on that line is on the same plane as all other points on that line. We keep the line straight. Don't care about the...
Yeah, you've just said plane,
parallel.
Right?
Don't care about the parallel.
You've just said plane, right?
Plane.
Yes,
plane. If they intersect, they are not parallel. Get it?
Yeah, exactly. They
Yes,
would not fit the
parallel,
definition of a parallel line. Would they? If they intersected, they would not be parallel.
You can't tell me lines are parallel. Two parallel lines.
I've just read you the definition.
No, you can't.
I've just read you the definition. What are you talking about?
Yeah, we're at the definition stage. We're not testing anything. We're just agreeing on, do we agree that parallel is two lines that don't intersect? We're not testing if any actual lines are parallel.
So what?
We're just agreeing on parallel.
So two parallel lines do not intersect. How did that curve the radius?
When I said curve the radius, I was talking about when you take measurements, like for angles and such, you don't curve the line. Right? Like angles are based on straight lines. If you curve or deviate the line used to make an angle, you're not going to get a proper angle or distance.
No one curving the line.
You do when you, in your model curve, you don't have a straight line because your quote-unquote straight line is a circle around the Earth.
We live on a sphere. What do you mean our model? Our model is a sphere. It's curved.
Yeah, but that doesn't a sphere doesn't have a straight line on it. This is what I'm trying to tell you.
Really?
The straight lines would go off into space. You curve the straight lines and call them geodesics.
Yes.
Okay, so I understand that. But the problem with that is you have to make a sacrifice. And one of those sacrifices you make is the straight line itself, because you've now said all straight lines are microscopically curving. So you don't have horizontal lines.
No, that's not what they say, actually.
What's the problem? I don't understand what the problem is. I need to sacrifice. I live on a sphere. I didn't choose to. That's how it is.
You chose the geometry that's used to
No, I
describe the way
didn't
we
choose
live.
the geometry. The geometry is there. I just measure it.
Which
to be what it
which
is.
geometry
Okay,
do you
so with
use, please? Jake, which geometry are you using when you say the geometry is there for you? Jake, has that gone quiet?
Which kind of
Sounds
geometry
like
do you know?
Zanick's mic is open somehow.
I'm sorry, but
He's not
I
going
got
to be using
unmuted.
Euclidean geometry. We know that.
Jake, please, before you interrupt Zanick
Sorry?
and get chance to do this, Jake, can you just tell me which geometry you are using on the thing that you think you live on?
To do what?
What you just said, the geometry was there for you. I asked you which geometry that is.
Which geometry I use?
Yes.
just say
Or
both.
which geometry it is?
Yes. Which geometry?
For what purpose?
For measuring anything.
Measuring, I can use Euclidean.
Okay. So would that be measuring the earth as well, like surveyors, if you were to do that? I mean, I know you don't actually do any measuring or any surveying yourself, but would you imagine that they use Euclidean geometry?
Sure.
Right, so all of the rules within Euclidean geometry that are laid out about straight lines and parallels and perpendiculars, triangles, all of those things, they stand in reality, don't they? They're the rules that we use whenever we're doing any measuring.
Sure.
Yeah. Okay, so when we say that the definition of parallel means that the lines don't meet, that comes from Euclidean geometry, and that's laid down. It's an axiomatic system. Do you know what the entire encapsulated Euclidean geometry being an axiomatic system involves?
I don't get what you say.
Well, it has definitions of all of the words and everything, so everybody understands. Then you have the postulates, which are the way you actually form the shapes and do that with however you're doing it with pencils and pens and rulers and compasses and all of that. They're the rules of how you depict the shapes that you're going to do within the thing. Then there are the axioms, which are classed as the common notations. They're the sort of self-evident rules of life, and they're classed as so simple they don't really need to be wrote out, but you do anyway because they're just self-evident things, right? So once you've got all of them together, they then take that, and that's everything that you need it to enable you to perform the geometry, right? And it's so intrinsic within logic and logical systems that you have proofs that prove everything that you've just been told earlier. So it's an axiomatic system that works back on itself, checks itself, and you get actual proofs that prove all of the things that come before, the definitions, the axioms, the postulates. It's all proved, it's all needed, and it's all been there for supposedly over 2,000 years. Right? So they're the rules that we work to. We don't go past them. We don't imagine anything different. I don't particularly. I personally, I can't break those rules. That's why I'm saying I'm not a flat earther, because the earth isn't flat. There's topography. I can measure that within surveying, right? But there is no chance geometrically you can have a ball model. It doesn't work.
No chance.
No chance, yes.
Did you measure
Absolutely, yeah.
Did you measure it?
Did I measure it?
Yes. Yes. How do you know it's not?
I can, well, we say perpendicular, right? The
We
vertical and
again do
horizontal
perpendicular.
are perpendicular. Now, within the rules of Euclidean geometry, do you know what perpendicular is?
Again?
Yes.
Why again? Why?
Because
you
it
forgot what we talked about
proves
before.
to you that a perpendicular is two straight lines. If one of them turns into vertical, that's a plumb bob, and the other one turns into level, horizontal, right? Then the level / horizontal turns into a plane because of the three-dimensional function of it. The vertical turns into your Z coordinate, and the horizontal plane that you're working on is the X and the Y plane. It's that simple. And it's a straight line. A plane is a two-dimensional surface. And I'm sorry that you can't understand.
We're learning geometry now? Are we learning geometry now?
No, we did this the other day. You might be learning it for the first time, but we did this the other day.
I know geometry to some extent, I can say.
Okay, so can you show us with surveying techniques or whatever, however you want to show us, how you end up with a curved water surface, please?
Two plumb lines are not parallel, therefore...
I know. You've just seen Jeff. Jeff's told you...
They are not vertical to a flat surface.
Yeah, because Jeff told you.
No, Jeff told you.
Yeah, Jeff told you.
Every surveyor will tell you.
What, that verticals aren't vertical? Or they're not the same vertical? They're different verticals?
Not the same vertical, yes.
Every surveyor. Do you know how many surveyors actually... Do you know how many surveyors actually deal with vertical? Maybe holding the measuring rod
with
vertical.
Not those with the auto level.
Not the ones with an auto level.
Yeah, those the
guy with the measuring rod would have to hold that vertical, wouldn't he?
Not really.
But the tool, the level, is a horizontal. Right, so you're only looking for a vertical distance, aren't you? From the horizontal plane.
At that point.
At which point?
Where the auto level is.
Yeah, but that's not where the measuring rod is.
Doesn't matter.
It does, because it's not at the point where the auto level is. It's a horizontal plane. It doesn't. That's not much of an answer. It's a horizontal plane. You do understand what that means? Two-dimensional surface. Do you want me to get you a mathematical thing for a plane? I'll put it in the debate discussion for you.
They need to be happy that the world doesn't behave like they think it does, with level curving down and horizontal and vertical bending into the inside, or all of our construction over long range would be all fucked up. Thank God the people that build everything are using a flat plane in Euclidean geometry.
In mathematics, a plane is a flat two-dimensional surface that extends infinitely far.
You don't live on a plane.
But the horizontal plane is a horizontal plane, right?
No.
Yeah.
A
two-dimensional surface is a flat...
You don't live on it.
But a two-dimensional surface is a flat, right? You would give us that. A plane is basically just a sort of the mathematical term for flat, right? Would you agree?
Yes.
Yeah, so a two-dimensional surface is a flat.
Right.
And we agree that there is mountains and valleys and stuff like that, which makes it a three-dimensional surface and not a flat. But the water level is horizontal, and the horizontal is a horizontal plane, which is a two-dimensional surface.
No.
Yeah, that's a we just said you've just done it again. You're doing quite well at this, Jake, by saying yes. No.
Measure it. Go measure it. You will do your.
We've got a test, yeah. We've been doing it the last 2 weekends.
8-inch drop over mine.
Who's told you that? Is that Jesse Kozlowski, right?
Told me.
We get find that.
What do you care? You watch and see.
I'll get it so everybody can hear it. Jesse Kozlowski, you can measure it. He says.
What, the drop?
Yeah.
8-inch over a mile.
Yeah, he's must be the one that told you it can be done. Right? That's where you've heard it. Jeff's told you about his plums not being parallel, and Jesse's the one that's told you that you can measure it. Right? I'm just going to play it now.
You can measure this. The level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared. You can measure this. Oh, yeah, it's measurable. The level surface. You can measure this. Have you tried measuring this? Oh, yeah, it's measurable. The level surface drops down. Oh, yeah, it's measurable. From the horizontal plane, drops down. Have you tried measuring this? You can measure this. Oh, yeah, it's measurable. You can measure this. Have you tried measuring this? I did not say that the level is not horizontal.
I'm saying, personally, I believe the things that you teach your child, your autistic...
Goes on to fight the flat earth, doing the thing at the end. But yeah, Jesse Kozlowski says you can measure this. The water level drops away from the horizontal. So that's what sort of like, I'm sure he was saying about the test that we were planning, or what the one we're doing. First of all, we establish the horizontal, and then we just add a water level to it. It's quite simple. It's basically what you were saying, right, Jake? The water level drops 8 inches from horizontal. And since the horizontal, or a horizontal, or level, is what surveyors deal with all the time, then all they've got to do is set up a horizontal line over a mile. Should be, you'd imagine that's quite easy for surveyors. Especially your ones. I mean, have they ever mentioned anything about that, Jake? Jeff and Jesse, the videos that you've been watching. Anything about establishing a horizontal over a mile?
I told you the method. You don't need a horizontal.
You don't need a horizontal. Well, it's perpendicular. It's perpendicular to vertical.
Any angle will do.
Any angle will do.
Yes.
This is amazing.
And any angle will do for what?
To see the total, the sum of the angles of reciprocal observations.
Did Cleary tell you before? Did you ever go over that? What reciprocal leveling is?
No, he didn't.
No, oh dear.
What is it?
What do you imagine it is?
What's reciprocal?
Yeah, what do you imagine then? Right? You say you've got two theodolites, right? one at point A and one at point B, but there'd have to be quite a distance between them, right? Because you don't use reciprocal leveling for that anything. Yeah, you need a big distance, right? In order.
No, you don't need such a big distance.
Yeah, you do. You wouldn't use reciprocal leveling.
Those instruments measure a second of a degree. And that's very little. It's 1/3600 of a degree.
Yeah.
It's very small. You don't need long distance.
Okay. And you know why they take measurements from each side, from side A and side B?
To have the total angle.
Yeah, it's to even out for any errors, because what you have to do is, you see, you only use reciprocal leveling when you've got a big distance that you can't do the individual ones. Like, let's say over a massive gorge, or there's a river there and you can't put your level in the middle of a river, so you need to go from one side of the river to the other. So, right, and because you've got to do it, and all sorts of different effects can take place, you can't do it 1 week from one end and then the other week from the other end, because the effects could be different. So what you're best off doing is doing it reciprocal, doing it at the same time, one at each side, right? Then they both look at each other and they take all of their measurements and everything from one point to the other, and they even out the differences, right? They don't measure a difference and try and get a slope. They even it out because it's a long distance they're looking for.
Yeah, how would they even it out?
They just take all of the measurements, and if they're the same, then they say brilliant. But if they say we're 5 mil out on this side and we're 5 mil out on that side, then we can even it out and say maybe 2.5 mil there. Maybe we'll check it again. We'll check it again at another time and make sure.
They don't measure millimeters.
Pardon? Sorry?
They measure angles.
Who measures angles?
Theodolites.
Yeah, but you don't have to use a theodolite. You can do reciprocal measurements with an auto level.
Really?
Yeah,
of
course you can.
How do you measure an angle?
You don't measure an angle. You just measure distances. Jake, you don't know what you're talking about, so...
No, you don't know what you're talking about.
Really?
If you have an auto level, and you see my auto level, 8 inches below your level.
No, not the level. You measure to a measuring rod. You don't look at other auto levels.
How are we going to even it? How are we going to even it?
Sorry?
I see your auto level 8 inches below mine. You see mine 8 inches below yours. How are we going to even it?
do you think that could happen?
We are level.
Right.
Can we call it we are level?
You think we just look at them from a mile away?
No, he thinks you can look at something and have it be below you, and then go to the other side and look back, and then have that below you also.
Do you have 2 auto levels?
Going uphill both ways.
Yeah,
cool, right?
it's fantastic.
Do you have 2 auto levels?
Jake, who's told you that? You've been watching Jesse Kozlowski videos, haven't you?
Do you have 2 auto levels?
They've got something to answer for this. Jesse Kozlowski and Jeff. You best come and start talking, because you've got people talking rubbish.
Do you have 2 auto levels? Try to get another one. I'm very curious to see what you'll get. Level 1 with 1, and then see what you
horizontal, Jake.
You will have 16 inches drop.
Jake, Oh my! You go and get an auto level, or just look into it a little bit, please, please, because you're making yourself look like a fool at the minute.
Bro, construction uses this thing called daisy chaining, right? Like you can daisy chain together these straight lines, and that's what they do, man. This is how this stuff works. If you have 3 points, right? You have your A, your B, and your C, and those are horizontal from A to B and then C from B to C. If you connect another point to Z to A and then a point to C, they're going to be along the same horizontal, and then you just keep going. This is how it works, man. You don't start going down this imaginary slope, but you keep your horizontal. That's beyond belief.
Auto levels, mile apart, level one with the other, and then try to see where.
Jake, please don't just say things that you don't know what you're talking about.
Very simple.
I was going to say you wouldn't use 2 auto levels. You would use an auto level and a grade rod.
Thanks, Rodney.
Shooting 2 auto levels
what does that
at each other from a mile is not going to accomplish anything.
What does that tell you? You can't use 1 auto level and rod. No, for one measurement, you can't. You need 2 rods.
Well, you wouldn't take just 1 measurement.
You need 2 rods.
I just want to know.
No, you can do it with 1 rod. You can do it with 2 people. 1 person with an auto level and 1 person with a rod. You just take back shots and 4 shots as you go.
Yeah, you need back and forth. Get it?
Yeah.
Yeah, but not back and forth with 2 auto levels like you said.
Am I on server mute?
Who's that?
It's Rob trying to ask something.
Yeah.
You can use 1 rod, and just what guys got to just do some more walking, that's all.
How many surveyors we got on the panel right now?
Well,
only one.
One definite one, right?
1 definite.
Yeah.
And then Chikey tell that guy how to do the survey.
Yep.
Okay, I just want to make sure.
Yeah, I'm not talking about me, right, Jake? I just have a surveying qualification from a few years ago and surveying experience. Yeah, I wasn't though. I was talking about Rodney B, the guy that you were just talking to. An actual,
surveyor,
yeah, an actual, real, professional surveyor. Yeah, imagine that.
And he said Earth is flat.
Pardon?
Did he mention those words, Trike?
No, I'm asking.
Oh yeah, I am a flat earther. If that's what he said.
And you're a surveyor.
Yes.
Oh, that's a hurt, don't it, Chikey?
Oh, there's a whole world of hurt in there for you, Chikey.
Yeah, I want to see some measurements you had. Can you?
Measurements?
What kind of measurements?
I want to see some surveying result that show that Earth is flat.
You mean all surveying that's done on a flat plane? You want to see the results of that, yeah?
Right.
Well, go and talk to a surveyor then, Chike. Oh, actually, you are talking to a surveyor. Rodney?
Which, can we just show you an auto level that establishes a horizontal plane of reference? Would that be enough to show you that a horizontal plane is possible? No.
You would think they would. You would think they would.
We were
love
talking
a
about
horizontal.
reciprocal. We were talking about reciprocal measurements, right?
Bro, if you had this nice horizontal, right? That was we've established this beautiful horizontal. You should be extremely happy because then you could just go look at the Earth curving under it.
Yeah.
Look at it.
Yeah,
look at it.
that's what
10
you
miles
see.
away at 600 feet up.
That's what you see.
No, you see something appear to get lower, but then when you go through the measurement process, you realize that it didn't actually get lower. That
get lower.
No,
Chikey, why are you talking over people every time?
No, I say appear.
It's
So now you
terrible.
can take measurements also, right?
Clouds
Because it's only
are in.
appear to go
No,
under.
when you
So
have a
how-
physical, Like a water level is a measurement that you can use this tube of water to establish the horizontal over a very long distance, very long. I mean, a big enough pipe, miles of horizontal you can establish what a water level, because that's what water does. It works its way to an equilibrium. Well, that is what you say, and I'm saying, you look at water. You look at it, guys.
Look at water.
This is how they
You
define
see
it.
one side of the water. You don't see the other side of the water, and you decided on a flat plane. How did you do it?
How did we decide flat is flat?
Yeah,
Or
take a
horizontal is
water level
horizontal?
over 1 mile at sea level, and stick it 1 foot above the ground and see if you can see the other side. You can't.
Well, see here, Jake. This is where you fall into a. Hold on, let me explain. Let me explain.
See them. Why?
If you want to give up the horizontal that the water level makes, that's fine. But you also give up your standard, which you then can say your Earth is deviating. So if you're going to say, well, everything is going off, bending into the distance, then you can't prove that it's like Earth curve. It's just what happens when things go off into the distance, right?
No.
Like you've got rid of your horizontal.
No.
You've made your horizontal curve. So you can't have your cake and eat. This is your problem. You can't have your cake, which is your horizontal standard, and then eat it, which is the deviation from it. When
Yes,
you make, but you're making the standard the deviation from horizontal. You're using water that bends. I'm saying in my world, in the real world, you can use a water level to make a 3-mile horizontal. You're saying that horizontal won't be a horizontal, it'll be a curved arch.
Yes, it'll be a curved arc. Exactly. You've broken the code.
Oh, well, that's not a horizontal. You've now given up your ability to establish
Correct.
a
It's not a
horizontal
horizontal.
So you've given up your ability to establish a horizontal over a long distance or
Well,
at
yes, what
all
happens when
because
you
you've
run over a
curved the
curved surface?
standard.
That's exactly the reason.
But that's fine. But you've given up the horizontal standard. You've given that up by subscribing to this whatever you just said there. So it's a pick and choose. You can't have it both. You can't have, hey, we're going to have this horizontal standard that is flat and level, which we can measure deviation from, but have your horizontal standard that's flat and level curving around the whole Earth. Can't have it both ways.
Now we got fucking crickets.
While there's crickets, shout out to Stanley. I'm crossing this bridge right now.
Is it? You were over the hump yet in the middle?
Yeah. No, I'm going up apparently towards the hump.
Shout out retracted. Shout out retracted.
It's actually amazing how horizontal they get these things, right? That's the amazing part. People
yeah,
wanna
it's been
take that
measured.
away from them. Yeah, they measure it, I know. They establish a horizontal off of a benchmark on the land, and man, are they good at keeping it that way. It doesn't curve at all until they want it to, so boats can go under. That's more of an arc. And then when you stack the photo and compress it, it exaggerates the arc of the bridge that's built as an arc. And you can sell it to the public as Earth curve, no problem. Then get your good friend to put data points on it, which all he did was follow the arc of the bridge, and voila, you're
Hey,
famous.
Clary, you remember you remember when I took Blender and I a section of Pontchartrain and I actually highlighted or increased the elevation data of the bridges, and you can actually literally see the arc.
Where we get the elevation data of the bridge?
So I don't know who saw that, but I've gotten the elevation data from NASA, and I applied it to Blender and laid it over Pontchartrain and increased the elevation data, and literally every section of the bridge that was arced, you could see it increase as I increase the elevation. Meanwhile, in between the arcs, it's completely horizontal. Priceless. And what do you think Soundly did? Soundly zoomed in on the arc, trying to hijack optics for Earth Curve. It's quite pathetic.
NASA have the elevation data for the bridge.
Yeah, so if you go into Blender, you can just go to YouTube.
Jesse got it. Jesse
want to
got
do-
it. Jesse drove over there. We put a thing on his roof. You not remember? When he was helping Soundly and Walter Bislin make his model for the curved thing to support Soundly's curved bridge picture. Yeah, Jesse drove over it. I'm putting it in the live stream text right now. I think it might just fit in. It's 95. But yeah, he measured it. It's about 5.8 meters above the water level all the way across. Apart from them bridges like they were talking about.
Oh, so it's the same level all across.
Yeah.
What did you say, Rakia?
It's the same elevation apart from the
What
bridges.
did you say, Rakia?
Horizontal.
Yeah.
No, you said it's the bridge is built in an incline. It's not level.
He was taking the piss.
Yeah. Yeah, Chuck, you want me to explain?
Yeah, I want you to explain.
Hey, Chaiki, you think when you enter that bridge, you go up from the land onto the bridge, sir?
I don't know. I haven't been there.
Yeah, exactly. And you're telling someone who drives over it weekly.
No. So you have
About
an
the
argument with you have an argument with Bev now that says that it's
No, I don't have an argument with
five whatever feet above the
Yeah.
water level.
Yeah.
All across.
Yeah, and guess what? The land is lower, right? So as you drive up
I
onto the
don't care
bridge,
about the land.
and then it levels out to horizontal, and then you drive to a bascule, which is where the boats go under, and then it goes up, comes back down to horizontal, and goes for another, and then goes up and back down to horizontal. It's amazing. And then when you get to the other side, you go down an arc, basically, to the land again. Which, oh, by the way,
Over what distance? Over what distance?
24 miles, 23.8 miles.
24 miles decline. From what to what?
I don't know what you're asking, Chaiki.
I'm asking. You said you go down to the land. I'm saying over what
it's
distance?
about a half a
you're
mile.
in the decline. Half a mile.
A half a mile.
That's,
Yeah. Each side.
But
yeah.
that's not what we see. That's not the curve we see.
I got a good picture of it. Actually,
Yeah,
I'm
but
going
that's
down
not the
one side
curve
right
in. That's not the curve in Soundly picture.
now. Yeah, you know why? Because there's no curve. That's compressed photo, sir.
The compressed photo.
Yeah,
There
compressed.
is an obvious curve there.
Chike, you got a guy there that's saying he goes over this bridge on a weekly basis. And he's got footage of it, you know, he's got pictures and you're
just
willing
got off
to
of it.
take. Yeah, you're willing to take the work, you know, like a picture that you can see that there's some severe atmospheric conditions there, along with other things. And you're going to take Soundly's Bridge picture.
Soundly Bridge
Hold on,
was
I'm finished.
taken in a great observation conditions. Great.
Oh, right, okay, so, I see. Thanks for that.
I can see the bridge almost all the way to the other side.
Is he breaking up or is that me?
You Chaiki.
Yeah.
He was breaking up a little bit.
Okay.
Because he's talking shit.
Why is it called Soundly's Bridge as well?
Beats me. That's what everyone calls it.
Let's call it the bridge over Lake Pontchartrain. The flat and level Lake Pontchartrain. You know how deep it is, Pontchartrain? Is how deep is it? Do you reckon?
No clue.
Rakia?
It's only like 8 to 16 feet deep, isn't it?
Oh.
It's not deep at all.
No, I thought it was like it's like a floodplain or something, isn't it?
Well, the lake is Lake Pontchartrain. There's Lake Marpol right to the to the west of it, and then there's a floodplain that empties into Lake Pontchartrain underneath the railroad bridge, and they have locks, ways they can kind of monitor that. But the lake itself has some pretty deep parts, up to 20 foot. There's some channels also. There's a couple rivers that empty into it. I was actually, for the hurricane, I was going to go underneath the bridge and go into a river. My buddy has a house on that river where I was going to dock my boat, but we ended up not doing it. But, you know, so it varies. I mean, you have some 5 foot parts. You know, it's not a constant everywhere.
So that water gets quite a high temperature then, really?
Oh,
Yeah.
yeah. It's a warm lake, and you get a lot of cold Mississippi overflow water, the snow melt water. Now, by the time it gets to Louisiana, the river water is relatively higher, but it's snow melt, basically, that's coming through the floodplain. And for the last 3 years, maybe even 5 years, the Mississippi River has been way up. Like, all the dirt pits that we get dirt from, they're closed down because the water's so high. But they control that. The spillway is what they call it. When they open the locks, they let all the water go into the spillway, and they control that farmland, and they do a lot of crawfish and stuff like that, so it's regulated. But to control the flooding in the area, they built the lock system and spillway system. And it's just a huge open area that water flows in instead of flowing into the, towns and cities, whatever. But it all comes through Lake Pontchartrain eventually, basically. A few other river systems and places towards Lafayette that allow the water to drain south, but most of it comes through Lake Pontchartrain out the Mississippi. So the delta of the Mississippi is southeast of Lake Pontchartrain. They have a lock system that you get in and out of the Mississippi River into the Lake Pontchartrain. Pretty easy stuff. They have the Intercoastal Canal. Waterways here in Louisiana are used pretty heavily. They dig a lot of canals and stuff for the oil industry that connects all these things.
What would you reckon?
A lot of bridges.
Sorry, what do you reckon to the chance of that being a 21-meter hump in the middle of that bridge then?
I would say 0.
If the water level doesn't really get above 20 foot deep, then how do you have right in the middle of that bridge a 21-meter hump? That's nearly 100 foot, right? It's quite a long way, I think.
And I would suspect, right, if there was 100-foot, whatever you want to call it, hump in the middle of that bridge, you could get back, a mile, let's say, and actually see it. That's...
Yeah. Yeah.
I don't know. They never take their pictures from the side. They always take them from a certain angle that compresses them, and you get the full effects of refraction and a mirage and whatever else is going on. You zoom into any of Soundly's pictures, you can see where the mirage line starts, and it's right where the curve starts, or the apparent curve. Pretty simple to figure out.
There is no curve, Dave.
Yeah, I know there's no curve.
Tell me, how far would you have to be from the bridge to take a side view of it? We'll get all in the frame.
The whole bridge? I don't know. But I mean, to see 100 foot or whatever, you're not very far.
Foot is not enough. You need to see the whole bridge.
Well, would you agree if both sides where it meets the land is the same elevation in your model, and the middle is bulged up 100 foot? Wouldn't you say you'd be able to see that at some point from the side? I mean, it's 100 foot, Chuck.
If you're close enough, but you need to be very, very far.
How far to see 100 foot?
I don't know. What is your field of view? What is the length of the bridge?
I don't know. Smart people can figure that out, I guess.
People
You
with
say it's not possible, I say it is.
Oh.
I don't know.
No, we'll figure it out. Tell me the length of the bridge and the field of view.
Oh, you want me to figure it out for you?
No, I'll figure it out. I'll figure it out, the distance.
Go work it out for your globe while we live in reality, Chunky.
It's easy. It's very easy.
Let us know, Chucky.
It's very, very easy.
Off you
Yeah.
go then.
Taiki, how many other pictures of that bridge have you seen? Apart from the one from Soundly.
I haven't seen many. Well, I saw Rakia, but they are quite blurry. But Rakia have very good power lines.
Oh, Chikey, did you see the ghost boat?
Ghost boat?
Yeah. You should watch that one. Rakia's video.
Which one? The
Called-
one that disappear or reflected at the distance?
Sorry, Cleo,
Yeah.
can I just finish that last question about, because you did mention the power line. And
Yeah,
if I'm
go.
not mistaken, I think it's the one with the, you know, where they're like, the angles heading off to the vanishing point in a straight line. I think is that the one?
Angles add to the vanishing point?
There's a power line shot, and there's the Pontchartrain causeway shot. I'm not sure which one you're referring to. Are you there, Spot On?
Yeah, I'm here, mate. Sorry, yeah. Yeah, the power lines, yeah.
Yeah, it was Chikey was talking about Dave's took some good shots
Yeah.
of the power lines. Is that what you were talking about, Jake?
Yeah, he denies it's his, but I remember he posted this as his.
Yeah, okay.
Right, so you're saying
Now he denies.
Next to it.
Now he says it's from Soundly, but Soundly pictured the lines from the other side. So it's not the same.
Chikey,
Oh, that
would you
definitely
say
makes a
I
difference.
replicated Soundly's picture pretty close?
Yeah, you did good job.
Yeah. So his refracted, mirage, distorted image of those power lines are just like my refracted, distorted mirage picture of the power lines. Almost an
His
exact match, right?
picture, I don't think there is any mirage in his picture.
Yeah, yeah.
Welcome
You
to
would
post
say
it.
that.
Come on.
So,
Come on.
welcome to Post It. It's been posted all over the world. All you got to do is look at it.
Okay.
Yeah, you know, when the bottom section starts disappearing right at the mirrored layer of wherever the water is starting to do whatever it does because of the atmospheric conditions, then all you got to do is go straight up from there, and that's when the top of the power line appears to start curving down, and voila, magic.
Whose is that one,
Right?
Jake?
Think that's a coincidence, Chikey? You think the curve starts curving that sharply down, sir? Do you really think that?
Yeah,
Or are you some type of paid
8
shill?
inch per mile square, yes.
That's not 8 inches per mile square. Draw your horizontal line across there like you so like to do in red. Measure the drop from there, right?
I asked you for the distances between the power lines.
You can find out the distances for yourself.
Yeah,
I don't do anything.
I've just put that on there actually, Jake. The one that Mick West actually put out when he was doing his Pearl Q perspective compression one, and the one in the top right nearly looks exactly the same as that one that you've posted, doesn't it? Would you not agree, Jake?
Yes, yes.
Yeah, so which one is that top one, the one that you say is Dave's?
Well, Dave posted it.
Okay, right. So that bottom one there, what about that bottom one that Mick West posted that claims that is Soundly's? Because I can get the tweet that he also did to me afterwards that claims that that very picture there is Soundly's and explains how Soundly's done perspective compression. That is the perfect example, those bits there.
It's almost like you can't tell them apart, right, Chikey? And about 200, 300 days out of the year, you can get that same image. You know why?
It's okay, Chikey.
Because it's horizontal.
Poor Chikey. Oh my goodness.
Yeah, that's pretty unfortunate. That
Stanley's been fooling you, Chikey, man. He's been fooling you with photos, with fake surveyors. He's been telling you a whole bunch of stuff. He's got you out here representing him, and he misled you, man.
He's been representing the surveyors. He's represented Jeff. He's represented Jesse Kozlowski. They've just put videos out. Chikey, you're out here making a fool out of yourself for these people who have lied to you. You should be having a word with them. I mean, you should be getting them to come here and explain themselves, because...
You know what, Chikey? We've been telling you the truth all day. Do you believe anything that we said?
Sorry?
All right, sorry. Chikey, we've been telling you the truth all day. Do you believe anything that we've said or shown you?
You told me truth. Did you bring one evidence for what you say?
That's all we've brought you.
Do your words because
Geometric
I
proof.
tell the truth. I tell the truth. You should
Geometry
believe
has
me.
its own proofs.
Geometry has its proof.
Yeah. Geometry has built-in
discussing
proofs.
Geometry or
You asked if we'd given you a proof all day.
Yes, I know
And
geometry.
has its own proofs.
Thank you
so
very
yes,
much.
we have.
No, you haven't. Because they
So
have
now
nothing to do with
Geometry
no,
doesn't
you
have
told
its
me
own
about
proofs.
geometry.
Is that true?
You told me about geometry, which does not have anything to do with reality.
Your reality.
Geometry. Earth measure.
Earth measure?
Geometry.
Show me one. Show me one. Go ahead.
Jeez.
Go ahead. Show me one measurement of Earth.
What do you think geometry means?
What the fuck you talking about geometry again? We're talking about Earth now. Measurement.
Wow. There's a sound bite in that.
Yeah.
For sure.
You guys do not even qualify as clowns.
Dear.
An unqualified
you make
clown.
bad jokes.
So geometry has nothing to do with Earth measurement then, Chikey, no?
No, he said geometry has nothing to do with reality.
No. What you're talking about has nothing to do with reality.
Does it have anything to do with Earth measurement?
Right.
I'm asking, does it?
Does not.
It does not, no?
Absolutely. Since you haven't presented any, so you have nothing to talk about, right?
Yep.
Just have a look in the debate discussion channel for us.
With those
for a second,
I presented,
will you?
those I presented,
Just have a quick look, Chikey. Just a
I'm
quick look.
starting to think you wouldn't know evidence if it got up and slapped you right across the face, man.
Try, do an effort, good scalper.
Pardon me?
Do an effort and slap me in the face with facts. Come on.
They have been all day.
All day long.
None, not one.
You just can't see him.
I was asked, flat is
Want to see.
parallel, is vertical, is perpendicular to horizontal. What kind of nonsense?
Hey, Jay, I got a question for you. I know English isn't your first language, but do you know what the word geo means?
What does it mean?
It's a car. It's a cheap car.
Have a guess, Chikey. If you don't know, just have a pop at the top.
What about geocentric? Have you ever heard of that?
You want me to Google it?
If you like.
What about geography? Geography.
What about geothermal?
I don't want to give it away, but
geometry.
Geometry. Geometry etymology. Type that.
Go on, have a go, Chikey. See what you come up with.
What about Geo Aloysius?
Did you look it up, Jake?
I think he's Googling it, and the whole world is waiting.
Yeah, I have. What is it?
What does it mean?
What is it? Come on.
Oh. You need it.
Chikey no likey. You could just click on debate discussion, and there's your definition right there. Click and look.
Well,
Click
just
and
I'd
look.
like to apologise.
You could also look up the etymology of the word geometry.
Totally.
I was laughing earlier, you Chikey. Only a couple of times I sniggered and just, but no, I apologise for that, mate, because, well, you know.
Because why? Because why? Well, why are you apologising?
You know, when if someone doesn't understand something, it's like, I just shouldn't be laughing, you know what I mean?
Yeah.
No, but you've just
So
been
what don't
completely
you
vindicated
understand?
for
I
laughing.
wasn't laughing. What don't you
No,
understand?
I was laughing when you were saying a couple of things earlier, and I was like I just
what?
sort of sat back and thought I was a bit.
Yeah, like
Yeah.
what?
Oh, I don't know, just a couple of silly things. That was all. We can move on now, but I've apologised. So.
No need.
Well, spot on. At least you didn't say "shut up." No, I won't say it.
Like horizontal being, like level being horizontal type, that would probably be one of the things.
I think you did actually laugh when he came up with the tilt that curves and slopes away from you over a hump.
Yeah, yeah, that.
I'm sure that's one time you did laugh.
That would have been worth a little bit of a giggle. That I must admit.
Yeah, I
have a
had to
serious-
hold that one in.
You know when I'm going to laugh, Bev?
Well,
Yeah, I do.
I know.
When he does his test.
I
When
found
the
it quite
water level-
amusing when you said that you trusted what Jeff said and Jesse. That was quite
I
funny.
bet Jesse and
When
Sally
you-
are watching right now,
Yeah.
laughing.
I have a serious question for Chikey.
When you see that water level on the other side drop 8
Rocky,
inches,
you're roboting a little bit,
say,
bro.
interesting. Like that guy, what's his name?
Drops 8 inches from where, Chikey? Where does it
his-
drop from?
From his auto level line of sight.
So there is an 8-inch drop over a mile from a line of sight.
Yeah.
That's what.
But didn't you
From a
didn't you
level
say?
line of sight.
Oh, a level.
Level
How do you
line of
establish
sight.
that level?
Ask him.
Ask
Don't
who?
ask
No, I'm
me.
asking you.
He will do it.
There
No,
wouldn't
I
be any
don't.
drop from your level line of sight because if level
We
follows
will-
the curve. If level follows the, if level follows the surface of the Earth, then there would be no drop from your level. It would
course,
show you a
level-
zero.
Because level
No.
follows the surface of the earth, but the straight level line does not.
But what straight level line? You just said level is a circle around the Earth. So how are you showing deviation
Yes.
from a circle around the Earth that follows the Earth that won't show you
From
any
a
deviation?
straight level line.
How do you do that?
Straight level line is
Oh, you
only
mean a
leveled at
Are you talking about a
a
horizontal now?
Yes, a horizontal line. Yes.
Hey Bev, yeah, maybe we
Sorry.
should tell him how a
Horizontal
horizontal.
line.
Yeah, horizontal
And
level.
Bev say, and Bev say interesting.
Yeah, because like a horizontal level.
I will laugh like I never left before.
But Chike, you
And
told
then
me
we can
Bev wasn't going to do it, Chike. You told me Bev isn't going to do it.
You don't know. I told you you don't know what Bev is going to do.
But
No, you
do.
told me he's not going to do it. And you also made a prediction that he's going to be out, what was it, 4 inches?
On a slope, yeah.
What was your prediction?
No.
4 inches?
No, it was the tilt you predicted.
My
wasn't
prediction
it,
was.
Chikey?
My prediction was. My prediction was for his differential leveling run.
Yeah, by 4 inches, 2 inches. You said That's what he said. He would have a 2-inch error, is what he told me.
Or more.
Or more. Perfect. That's a lot of 1 millimeter errors.
Hey, Chike, I got a question for you. You believe that the Earth curves 8 inches per mile square, correct? That means at 3 miles there'd be a 72-inch drop, right?
Roughly,
6 feet.
yes.
Okay. So what if I told you can take the angular slope of the human eye, which is for a 5.77 foot observer, you can take 0.0213 times it by 3.14 divided by 180, sorry, and times it by miles, 3 miles. I'll get a hidden ratio of 5.8 feet. So I'll get the 70 inches hidden based on the angular slope of the human eye. No curvature. Have you thought about this when you were applying the 8 inch per mile square? Because, for instance, 3 by 3 by 8 equals 72.
Again, your formula again.
So 3 by 3, 3 miles, right? You square it, 3 by 3 times 8 inches per mile square, you get it 72 inches, about 6 foot drop. This is based on your ball math. Now, if we take the angular slope of the human eye of a 5.77 foot observer,
slope.
If we
human eye.
So what the ground rises. You have to realize this in your curvature calculator. Between the observer and the horizon, you have what's called an arc. Okay? You can conflate it as Earth curve.
No, it doesn't rise.
Well, that's your Earth calculator. Deal with it, okay? There's an arc there. Okay?
No,
it's literally
it
called
doesn't rise.
So listen, it's literally called an arc. The bottom line is that the ground is parallel to the observer's eye line. Okay? But there's a convergence point at the end of that observer's eye line called the horizon. You've conflated that to Earth curve, and this is how you figure it out. 3 by 3 times 8 gives you 72 inches. Well, let's take the angular slope of the human eye, 0.0213, times it by 3.14, divide it by 180, times it by 3 miles. I get 5.88 feet of hidden using
588 instead of 6.
Yeah.
It's not good.
I'm not using 6 feet, buddy. It's just if you're going to complain about 2 inches. At the end of the day, dude, I just
because you find some numbers that did you good.
I find some numbers,
yes.
buddy. I didn't find some numbers.
Yes.
I actually used the slope of the human eye. Now, here's something you need to do.
What
go look
does
at
the slope of the human eye means?
Okay, so is the human eye a convex lens, Chike? Is the human eye a convex lens, Chike?
It's like a little ball.
Is it a convex lens?
It's like a little sphere, I'm telling you.
So it's a convex lens.
That's not what he asked you, Chike. Answer the question.
So it's a convex lens, correct?
Okay.
So that's a yes, right? Just play with me, bro. Just be a cool guy. And when I ask for a yes or no, you just go yes. Okay? Just don't look. You already look like a. You already look like a dick as it is. So the ground rises apparently, right? It's not actually rising.
But I wanted to understand what's the slope mean.
Okay, great. Have you investigated the eye depth of perception? Depth of field.
Slope. The human eye slope.
Okay, so in when you look at any literature regarding the study of the human eye, there is a slope indicated. In other words, there's a rising of the ground caused by the
slope indicated in the human eye. Can you reference me to where you read
yes, I can. Don't you worry, Chike. But I'm giving you the benefit of the doubt. I don't have the PDF right now to show you, but go do yourself a favor and research video game programming, perspective in video game programming. They account for what's called a slope. Okay, and it's a relative because the human eye is variant based on the individual, the degeneration of the eye, the healthiness of the eye, things like that are variable. But on average, it's a slope factor of 0.022 plus or minus other anomalies like maybe the shape of the eye, the muscle contraction, things like that. But there is a constant.
What is this slope measured by? What does this number mean?
Okay. The ground rises, does it not, Chaiki, to the horizon? Does it not?
No, doesn't.
Okay, it doesn't in reality, but it appears to, correct? Just like a hallway. The hallway appears to rise up. That's your slope factor. Okay? This is caused by the convexity of your lens. Okay? You see in a cone shape. You have a focal point. In around that focal point, you have a circle of confusion. Okay? So just looking down a hallway, you have a slope factor.
Spare me, please.
Yeah, I'm telling you the fact.
I have no confusion.
Yeah.
You do.
You
You've made that blatantly obvious.
Yeah, you are very confused because you are negating the optics of your human eye and what it does to the image in front of you. This is something you need to apply. Now, I just showed you a mathematical formula based on the slope factor of our human eye, calculating what's supposed to be hidden. Now, you have an Earth curvature calculator that accounts for a geometrical ball. I have one that calculates for optics. I'm going to go with the optics because in your Earth curvature calculator, you have an arc in yours, but no definition for slope, no definition for perspective. It's quantified as Earth curve. The rising of the ground to the horizon is quantified in your Earth curvature calculator. It's false and doesn't represent reality. End game. Welcome to Flat Earth, Chaiki.
A part of a circle is an arc, no? Isn't it?
Screw
The
that.
point-
I don't want Chaiki as a flat earther.
Yeah, no shit, eh? Yeah, he's
No
Just keep
worries.
spouting your nonsense,
No
Chaiki. Get everybody
worries.
else to join flat earth. We
No
don't need you.
worries,
Stay
Rakia.
yourself.
Won't happen.
The point is when the day you recognize the rising of the ground is not caused by a physical ball, it's caused by optics, then maybe you can start understanding when apparent lines of light converge. In other words, the horizon, it's a convergence. It's not an actual physical effect. It's an optical effect based on what, Chaiki? Not Earth curve.
Perspective.
Exactly. Has nothing to do with the Earth curve. It has everything to do with the angular relationship for a convex lens through an aperture, a circular aperture. That's all that's in relation to. That's why you can look down a hallway. If I was to draw you two images, okay, side by side, and I was just to take a piece of paper and I was just to draw lines into a center point, I could overlay it both to a hallway and a horizon because they're both a convergence point. There's nothing solid there. There's no magnitude there. There's nothing to measure there. It's an optical effect. Do you understand, Chaiki?
Just nod twice.
I understand perspective. Yes, I do.
Earth curve has nothing to do with it.
You don't.
Now, if you're being an honest person, you should.
Perspective never make things disappear.
Actually, you're wrong.
Doesn't
Angular.
Doesn't happen. Never.
Yes, Chaiki. Here's a test you can do. So stop being disingenuous. It does happen. Here's an example.
No tests.
Stop. You need to do this. Exactly. Just do yourself a favor. Take any camera you have. Lay it on the ground. Take an object. Take that object and move it away until you finally get to the even part of the frame of the camera. Okay. Now, if you the point is you could be slightly over, just a tad, even a millimeter over the center position point, and it will block any object moving downward. Okay, this is something that you can do over and over again to test for yourself.
You can scroll up. I posted a picture. That doesn't have a video. That doesn't happen.
So it does happen. You just don't want to admit it happens.
Never happened.
Chaiki, you don't want to do the experiment. You don't want to do the experiment.
I did. Why you say I don't?
You just said
the video.
You just
Why
said
you say no.
You just said you don't do experiments. You said there's no point.
No,
you just
I posted the video.
Listen,
the video.
It must be awful to be you to flip flop so much in your mind.
I posted the video. You see, you argue about facts.
I've already done it.
That was here know about.
I've already done.
Don't talk. Scroll up.
I've already done
video.
Chaiki, I've already done it. It's on my channel.
Video and see that nothing disappear. I don't care what you did. You did it wrong. I did it right. Nothing disappear. Never, ever, forever.
So there's no way
unless it's behind.
There's no way for you to do it properly. There's no way for you to do it properly if you don't understand optics. That's the problem with you. You don't understand optics. I just gave you Listen, I just gave you that formula. That's an optical formula based on the angular slope of the human eye, and it works. I can tell you the distance to the horizon with it. I can tell you what's hidden over 10 miles with it without using Earth curvature calculations. Do you understand? Now, here's another thing. Here's another thing I'm going to teach you what to do. Take the observer height of 6 feet. Figure out the distance. Just, if you like math, this is something you can do. Do you think that I could calculate the radius of the Earth based on the angular resolution of our human eye? Do you think I could do that, Shaky?
What the hell?
Do you think I could? Do you think I could divulge?
How tall am I? Based on your angular resolution of your eye, how can you tell something?
So listen, because it's optics, you can calculate the distance of the horizon if you understand optics. You're conflating it to Earth curve. Now I'm going to ask you again. Don't deflect. Can I take the resolution of the eye and figure out the size of the radius of the Earth?
No.
Well, obviously you haven't done enough research, but yes, you can. Okay.
I'd like to see that or hear that.
Awesome. So take a 6 foot observer. Take a 6 foot observer. So this is the math. Take 6 feet. Go arctangent. 6 divided by 15,840 feet. So 6 feet divided by 6, you'll get I think an angle of 0.217. Or sorry, 0.0217. If you take that 0.217 and you calculate it for the 6 foot observer, which is once, and then for the hidden, which is twice, so you're going to square the 0.0217. You're going to square that, and you are going to divide it by. Let me just do the math quickly here. Let me see. Give me a second, just make sure I'm telling you correctly. Sorry, I'm just going to enter this in here. Okay, so we can do this. You're going to go 6 divided by, so 6 feet divided by tangent. What's 0. Here, let's just square that. So it's 0.0217 squared equals. Or sorry, is it double or square? Hold on. I should have done this math before I came here. Yeah, so take the angular resolution of the human eye, times it by 2. So 1 for the observer and 1 for the hidden. So it's not squared, it's just times it by 2. If you take 6 divided by tangent of the degree 0.043, tell me what radius you get, Jakey.
0.043 to what?
Okay, so if you take if you take 6 feet divided by the tangent of the degree, which is 0.0434, I think, which is the 6 foot height and then the 6 foot hidden. So you're timesing the angular resolution by the horizon, and then you're adding the angular for the drop.
You're confusing terms again.
So you work out to be a diameter, sorry, not the radius, but the diameter of 7,921 miles by using that quick calculation. And that is just using the height of the observer, the calculation of the angular resolution, and then the hidden at the 3 miles. So it'd be 0.0217 times 2 gives you 0.043 roughly. And that will give you the diameter of the Earth right there, using optics and nothing to do with Earth curvature.
Oh, it has
and that
numerology.
It has nothing to do with numerology, bud. Nice try.
Yes, it is. You don't use your angular resolution times anything. It's a value that tells you what you can discern as being there or not.
Okay, so I can get the 0.0213 from the diffraction limit of 1.22. Do you know how to do it?
Yes, I do know. I don't think you do, though.
Awesome. It's really easy. You can times it by pi, divide it by 180, and you get the 0.023, or you times it by, or you times it by 57.3. So let's just do some quick calculation here. Or is it divide? Let me just see.
You're taking 4 divided by 2.
There you go. So if we took a 5.77 foot observer and we times his angular slope is 0.0213. We times that by 57.30. We get the
Slope isn't 0.002.
we get one point. We get one. Listen, bud. Stop obfuscating.
Numbers.
0.0213, which is the angular slope of the human eye, times it by 57.3. We get 1.22.
It's not the slope of the human eye.
Yes, it is.
Zanick, if you don't stop talking over him, I'm going to mute you again.
Yeah, this guy's a pylon, and he should be removed from because you're a liar, Zanick, and disingenuous to the human race. The point is, you can take.
We don't do this here.
Yeah, you need to shut up and actually start learning optics of the human eye and stop conflating it as Earth curve. You're obviously unintelligent when it comes to it, and I think you need to improve your skill sets.
It's amazing. I've made an incredible living knowing this technology. You don't, and I'm sure you don't use it in your daily life. So, just saying.
Right on, bud. That's your argument. People have used technology, therefore there's the ball. Nice one, bud.
Zanick is always so
We've already gone over how you found your coincidental numbers, multiplied them, and then divided them by the same numbers and got certain values that you get anyway. So you've made your circular reasoning has made your case, and that's what my point was.
No, you're obfuscation and don't even know what the hell you're talking about. I use simple mathematics to show you that there is a slope of the human eye, and the fact that you want to disregard that knowledge just goes to show you. Just goes to show you you're being disingenuous. You're not being authentic. You're not being authentic. Every programmer that uses a video game has to program for the slope of the human eye. Stop being disingenuous, Zanick.
The slope of the human eye from what?
Okay, so you obviously don't know, right?
I do know. I'm asking you.
What do you know, Zanick? Tell us what you know, please.
I know where the 1.22 comes from. I know what the wavelength of light is. I know what.
Where does the 1.22 come from, Zanick?
You tell me. I'm not going to give you your answers.
Classic.
I asked you the question. I know. I know this very well.
You're making assertions, so I would like to know. Please tell me.
No, I already said I know. I asked you the question.
You said you know. You said you know, so educate us, please.
I don't know, Zanick. I don't know, Zanick. Here's the best chance for you to tell us, right? Those of us that don't know, can you please tell us, Zanick?
Help us.
I literally said it a million times. I'm not going to do it again.
You say it repeatedly. You're here to help us.
Yep.
Help me understand, Zanick. Please tell me.
But he don't know.
Zanick. Zanick, tell me, where does it come from?
Help us.
Come on, you normally can't be quiet, so
there's safety in the mute button.
Please.
Honestly, Zanick, now is your chance, dude. Show them where flat data is wrong.
And help those of us that don't know something to learn a little bit more. Please, Zanick. Come on.
Please teach me, Zanick. Teach me.
Teach us the origins of the 1.22, please.
Very gratifying. No, I've already told you a million times.
No, we have never heard you before. So please explain now. Off you go.
Tell them 1,000,001 times, sir. Make it very clear.
Should have enough time to Google it.
If you already did it 1,000,000 times, one more time is not going to hurt you.
Yeah. It must be well rehearsed by now.
And
I assure you it is.
Wonderful living you made.
No, because it's just like when Quantum talks about this 1.22 and he actually confuses it with the diffractive limit. The 0.2 being the angle between your eye at 6 feet and the horizon at 3 miles. That'd be 0.02.
You sound like a PhD when you talk.
A lot of these things are just coincidental.
Angular angles.
To determine a diffractive limit, just because the 1.2 is close to 0.1.22, it's not 1.21 as the actual value is 1.219. It's not 1.22, which is a different value, but they're close, and so they can get confused, and you can get a coincidental value to make your case, and that's my point. You've done this a bunch of times, Flat Earth Data, and I'm calling you out on it again.
No, Zanick, please explain to us the 1.22. I mean, you just said that 1.219 is close to 1.22, which is quite right. It is, mathematically. You haven't shown us what it is, though, or where it came from. Please. Please expand on that a little bit.
I've told you personally, Bev. And I've
never
told
told
Alpha
me.
Data many times too, even though he talks over me. So
never
why should I
told
tell
me.
again? Just end up with the same
Zanick,
results I've always had.
Zanick, I've
I
not
want
been
him to
here.
tell us where it came from. That'd be more
Zanick, I've
interesting
not
to me.
been here the million times before, so indulge me. Where did it come from?
I'll PM you on the answer, and you can hold it.
No, Zanick, you can tell.
Would that be okay?
You can, you can tell everybody. You can tell everybody, Zanick. It's okay.
More than one person here that wants to know.
To be honest, Zanick, I've never heard your answer before either.
Yeah, he'll PM it to you. Don't worry.
What are you here for, Zanick?
I'm writing this down in my book, Zanick. I asked for help and you didn't give it. You said you were here to help me. I'm asking you personally to help me. Explain it. I'm writing this down in the book.
He's here
No,
to wait.
I'm
I am
waiting
here
for the
to help.
PM.
I am here to help.
Have you sent the PM yet,
But
Zanick?
this is between Flat Earth Data. I mean, he send this circular reasoning rant that he goes on every time he talks about what the angular resolution of something is, or how you can calculate the size of the Earth with 1.22, and then based on the angular resolution of the human eye being 0.02. And he said this over and over again, and he's starting to believe it. And it's just a bunch of hogwash.
Zanick,
Zanick, where's
what
my
is in
DM?
every limited diffraction system?
Every limited diffraction system. What is that? Can you tell me?
Oh my goodness, you don't know what,
What
that
is
means.
what is a limited diffractive system?
So that means either your lens is more powerful than your sensor, or your sensor is more powerful than your lens, and you have diffraction.
What do you actually ask?
The 1.22 is in every limited diffraction system.
And many times you throw out the 1.22.
Anything
You don't even
that has
need the
a
1.22
circular.
in most cases.
Stop
Most
interrupting me,
cases you
Zanick.
can throw out the 1.22.
Stop
Did you know that?
interrupting me, Zanick.
Oh,
Stop interrupting me.
Oh, go ahead.
Every limited diffraction system has a 1.22. Okay? Do you want to know where the 1.22 comes from, Zanick? It comes from the fact of visible
So do you
light.
know where the
It
diffraction?
comes from,
Do you know where the
it comes
1.22 comes from? It sounds
the
like you don't.
visible light that we most see, which is around 500 nanometers, 450 to 500 nanometers. That's where the 1.22 comes from. It's in every single camera, Zanick.
Oh, did you just tell him?
It's in every limited diffraction system, anything with a circular aperture. The 1.22 is in these systems. It's an angular limitation to light.
Why?
Based on
It's not an angular limitation.
every wavelength
It has
of light.
nothing to do with the angular
Every
limitation.
wavelength of light has a diffraction point, bud.
Really? What's the okay? Then okay, you just said something. What's the diffractive limit of 100 nanometers then?
So now you're gonna run off.
No,
Good
you
job,
made a
bro.
statement. I'm
Weren't
gonna
you
call you out
supposed
on it.
weren't you supposed to tell us about
You
the
see,
1.22?
now you see. This is why I'm not telling you, because you just gave me.
Oh, Zanick.
What
You just said something.
You said 1.22 is the diffractive limit of any wavelength of light. So I'm giving you a wavelength of light. Tell me the diffractive limit. 350 nanometers. Go ahead.
That answer there is exactly why.
See, you don't know what it means.
Do you want to do it? Here's how you do it. You take the 1.22, you times it by the conversion of 300 nanometers. So you want to convert it to meters. So is it 0.00000039? You divide it by the aperture size of the human eye, which is 0.005. You will get the radiance number of the wavelength of light, whether it would be 0.000, whatever you end up with. I haven't done the
No,
math.
that's not how it works.
Yes, it is, buddy.
It's a.
How's it work, Zach?
It's a Fourier transfer that reduces quite a bit more than that, but it's okay. You're close.
How close is it, Zach? To what decimal point does he close? Zach,
He didn't even give the numbers, Zanick, and you said he was close. You're a moron, man.
how many decimal points is he close?
His multiplication, he left out a few factors. He left out radius and he left out pi. But it's okay. He's throwing out. He's gone on the Google search and he found a bunch of values and he's trying to figure out what they mean.
Why don't you explain it in layman's terms?
Yeah.
Go ahead, Zach.
As though with little children, Zanick. You know, just come on.
Because, Zanick, I'm starting to believe this Flat Earth Data dude.
Yeah.
You don't want that.
Yeah.
You know I'm a smart guy. Just lay it out in layman's terms. Let's get this shit straightened out.
I've still not got my DM, Zanick. I'm still waiting.
Okay, do you know what the wave equation is?
No, explain it.
So it's not that easy to explain to you. I can give you the equation, but I don't think you know what it means.
No, you explain it. I don't need the equation. Explain it.
Well, we're waiting.
Well, try to figure out the easiest way to explain it without getting.
How about go away,
confused.
have some supper, and come back when you figure it out, Zanick?
That wasn't very nice, Rikia. He's trying to figure out how to dumb it down for me.
Well, yeah,
He's trying to be nice.
I know the equation, but I mean to try to explain it to you where they're derived from is a little more challenging to you because you guys are well, not you particularly, but mainly Flat Earth Data, who's come across a couple values, he's them in his little brain of his, and he's found some.
Yeah, but I asked you, Zanick, not Flat Earth Data. I said I'm starting to believe him. Help me not believe him.
Well, it's the lens equation.
I don't know. What is it? Where'd it come from?
Well, it's like ask me how Einstein came up with E equals MC squared.
Listen, Zanick, if I'm saying, can you help me, and you start giving me a pop quiz, that's not helping me. I'm asking for the answers, not for the quiz.
Okay, so it's basically the first circle in the Rayleigh criterion. When you see the discerning between two objects, it's that first circle. We're trying to find the diameter of it.
Wait, what? What circle?
Based on the lens equation. So 1 over u plus 1 over v equals 1 over f.
I think you gotta go back further. You're just spewing out. You're not explaining. You just want to go to mathematical formulas.
It's a number and it's based on math.
Yeah,
but
right. But where did it come from? What's the history? What's the etymology, if you will, of the equation and of the number? Because so I can understand it. Because to throw numbers at me doesn't really help me understand anything. It's just numbers. It's just mumbo jumbo if I don't know how, where, why they came from, right?
Well, it's a little more complicated than that.
Well, that's why we're asking, or at least me, I'm not, like, because otherwise I'm going to have to go with...
Hold on, I'm just thinking. I'm just writing some stuff on a paper. Hold on. Make a little drawing.
Take your time. Google the shit out of that.
A lot of math behind it, and I could break it down. Hold on, I'm trying to think about it.
I'm going to have to mute for a couple of minutes here, in like 2 or 3 minutes. I'll mute for 5 or 10, but I'll try to listen if you come up with something. If not, I'll ask when I get back.
It might be a while.
I think he's sorting out his DM to DP in the meantime.
Well, he's supposed to give me that one too.
I'm still waiting.
Well, it's a group one, right? Everybody's getting it.
If it makes you feel any better, DP, I've been waiting for like 6 to 8 months for information Zanick tells me about every month he's going to give me. So don't worry about it.
That's just taking the wind out of my sails.
Yeah, I'm sorry, dude. I didn't mean to do that. There's pretty much no wind there, really. It's just hot air. A little bit of hot air breezing over the Lake Pontchartrain. They give it a wavy effect.
Why am I not surprised?
Yeah, I'm sorry, man. I didn't want to let you in on that right away, but yeah. Okay, Zanick, I gotta mute for like 5 or 10 minutes. I won't be able to listen very closely, but you guys let me know if you make any great discoveries.
So you're trying to get the equation for, this is the Bezel function, obviously, and there's some calculus involved as well. But it's the first zero, the second zero, and then you have to, this is how you break it down, and it's not a simple. I can't even copy it.
Hey, Zanick, what did Bezel use the 1.22 for using his Bezel equation during the first order? What did he use his coordinate systems on to come up with the 1.22?
Well, yeah, so you get the 1.22.
So it's looking over the edge of something is where you get diffraction, right? You get a banding. It's light passing through a circular
No, it has nothing
aperture.
to do with it has nothing to do with that kind of diffraction.
So it's light going over an edge. The 1.22
No,
the
it's
first
not like
order.
that.
It was from a cylinder.
It's the
Okay?
it's the intensity of a
It
diffracted
was
light.
the edge of a cylinder. Its coordinate system is based off a
Fraunhofer,
cylinder.
Fraunhofer limit.
So
It's a Fraunhofer limit is which we're going for. So it's no, it's
point
not.
is the
It has nothing to do with
is
light going over an edge. So
the
you're not going to listen. This is
1.22.
why I don't want to tell you because you're just going to keep on
The
talking.
1
over.
point. This is why you don't want to tell me. You're a fucking
No,
idiot.
I know.
The
I told you. I just told you. You don't know what I just told you.
The 1.22 is directly related to circular apertures, Zanick.
Yes, it comes from that.
Okay.
It comes from a circular
Yeah.
aperture. It's
It's
the equation
in every.
of a lens.
Listen, buddy. The 1.22 is in every limited diffraction system. That means
Well, yes.
every single.
No, not every. You can throw it out most of the time.
That's right.
All you need to do is divide the wavelength divided by the diameter, and you can get a plenty close answer. You don't even need 1.22. So it's silly to even talk about it.
The 1.22 I can use to calculate the distance to the horizon, Zanick.
No, that's a whole different value.
I can calculate
That's
the
a whole different value.
So listen, Peckerhead, listen.
Value.
I can take the slope
Yeah,
of the
but you
human eye.
just got a coincidental number. You have the 1.2 miles. If you're 1 foot up the ground, there's
so I
the
can get out
horizon.
what I'm saying? Can you mute this fucker
Why
so
do
I
I
can get out what I'm
You're
saying?
just going nonsense.
Zanick, I can take the slope of the human eye.
There's no
right?
slope of the human eye.
Okay, you're a
Stop
moron.
it. My God.
So you're a moron. The ground
No,
rises
you
into the
are.
center focal point position. So I can take
But if I'm 6
0.0213.
feet tall, with
I've muted him.
Yeah.
Go on, flat Earth data. Carry on.
So listen, I can take, this is how I can do the calculation of the horizon just using the concept of angular or slope, the slope calculation of 0.0213 for a 5.77 foot observer. What I do is I times it by 180 divided by pi, I get 1.22101, okay? I can take that 1.22, square it, and divide it by the distance to get any kind of hidden. And this is all Euclidean. This is not physical sphere geometry, numpty. So don't tell me I can't take the slope of the human eye and turn it into 1.22 and then calculate the distance to the horizon. Absolutely I can. I can take any height of the observer's position, square root it, times it. I can take the
sorry.
I can take the height of any. I can take the height of
You
any
just said at
observer.
1.22. Hold on.
I can take the height of any
Can I say
observer.
something?
I can square root it
Can I say
times it
something
by
yes or no?
1 point. I can take
Can I
the
say
height of
something?
any.
Yes or no?
I can take
This
the
guy
height of
comes
any
off of me
observer.
and
Can I say something? Yes or no?
immediately
I can
What is
take
your
the height of
problem,
any
Zanick?
observer.
He's back on
Any
mute.
observer. I can square root it. I can times it by that 1.22, and I can get the distance to the horizon. Okay. I can show you how I can use the angular slope of the human eye to get to the 1.22 to calculate the distance. I don't need to think of the Earth as a ball, Zanick, to calculate the distance to the apparent horizon, because it's an optical effect, not a physical geometrical effect. That's why I can use my math that I've clearly used over and over again, that can be substantiated with quick calculations that confirms what I'm saying.
Right, I'm going to take him back off mute now. So, Zanick, you're off mute.
Okay, so you've already admitted now. Everyone heard you that the 1.22 something number is when you calculate it, and you gave it a few decimal places. The real answer is 1.219. That's how I know you're wrong. They're two different numbers. They're very close, but they come from two different equations. You used an equation, assumed it was a lens number, which is not, because the lens number is 1.219666989. And it goes on from there. Your 1.22 is a completely different number. They're very close, but they're not the same. So you can't just say, I'm still talking. You just can't say that you use this Earth curve calculator number, 1.2 miles distance from a 1 foot observer on the radius of 3950 as being the same as the lens equation value, which is 1.219.
Yeah, Zanick, you're just sprouting numbers. Just a minute. Flat Earth Data, you're roboting really badly there.
The bottom line is he gave me a value. It doesn't equal the lens equation number. And that's where it comes. Yeah, he's going to keep on talking. I can't.
Samuel Robotin.
Who's...
Beta, I think you're roboting super bad. You might want to drop and come back. No, I don't know who it is.
Yeah, he keeps
found a
closing
number
his
that was
mic.
close and used it in some presumption and came out pretty close to the answer. That's why I said he's close.
Okay.
But he's using the wrong number. And
Can I just point everyone to the thing? Was it Rodney B posted in the live stream? I don't know whether you guys in the other bit will be allowed to see. We'll decide. Everybody, if you have a look at what Rodney put, it's Labman's Physics ETU, and it's a module. It's quite interesting. If you look at it, it says about this. There's a bit in here where it tells you. It says, in geometrical optics, we can assume that an ideal aberration-free lens focuses parallel rays to a single point, one focal length away from the lens. But the lens itself acts like an aperture with a diameter d for the incident light. The light passing through the lens therefore spread out. This yields a blurred spot at the focal point. Right? Light near the focal point exhibits an airy disc pattern.
Yep.
The size of the airy disc is determined by the focal length f and diameter d of the lens. The radius r of the airy disc at the focal point of a lens is given by r equals 1.22 for the airy and the focal distance and all of that, right? So the 1.22 that he's talking about, the one in this paper, he's talking about looks like a blurry bit in the center of a focal
There's a center
lens.
one and then there's an outer one.
Why did you not just say that before? Why don't just agree with me and interrupt when we've just getting through this point and say that's what you were saying?
I'm muting you again.
It
Zanick,
wasn't what you were saying. Right, so that's a very, very interesting paper, right? Or whatever, I'm not too sure what it is, but I didn't understand what it was, and that seems to explain what 1.22 is. It's its relationship of a blurred point within a focus on a lens, and it does go on to say the resolving power of, it says all sorts of stuff. It's very interesting. There's even a bit at the bottom that says there's a problem. A spy satellite travels at a distance of 50 kilometers above the Earth's surface. How large that's not very high, is it? 50 kilometers? Not so sure about that. But a spy satellite travels of a distance of 50 kilometers above the Earth. That'd be a balloon, wouldn't it? Anyway, how large must the lens be so that it can resolve objects within a size of 2 millimeters and thus read a newspaper? I assume the light has a wavelength of 400 nanometers. And then it goes down to explain how you'd use this particular 1.22. And it comes up with 12.2 meters. That's at 50 kilometers.
Guess what half the size of the human eye is? 12.2 millimeters. If you convert that to kilometers, you get the radiance of 0.0. Well, in kilometers it would be 0.000122, which in the Rayleigh criterion, if you take 1.22 times it by the wavelength of light divided by the size of the aperture, you get 0.000122, the same as half of the cut off the eye. So it's totally hijacking of the circular aperture. One way I figured this out was putting 1 foot in, 1 foot high, 1 mile away, you get 1.22459 in the geometrical calculators. So it's complete hijacking of our angular resolution to the distance. In my opinion, anyway. So far.
I wasn't able to listen for a while. Did Zanick give the information, the straight note flat earth data? Because I want to hear.
No, we've been researching 1.22. It's everywhere in lens and angular resolution and all that. We can't find Zanick's number anywhere.
Well, Zanick seems to think there's a big difference between 1.19 and 1.219 and 1.22. I'm wondering if you did the calculations with 1.219 and did them at 1.22, what's the major difference there? Like, because he seemed to think it was a pretty big deal.
Well, I'll take him off mute and he can answer that point.
The point was
Zanick,
not how
you're
far
off
you're
mute.
off. The part is that where it was derived from, shown that he made up his. See, he's part right.
Well, at some point,
please,
Let
Zanick.
me finish. You have the
Zanick, wouldn't you say at some point
hold on,
paid around 0.001 up?
Never mind. What I was going to say is where they came from were two different values. And just because they're close doesn't it makes it coincidental. Bev quoted a paper that accurately described what I was trying to put in paper for you. And that was the focal length and some equalities there, and the Aries disk, and there's an outer disk and there's an inner disk, and there is a 1.219 value,
No,
which is
it
close
said
to a
1.22.
But-
Yeah, it's
of
very
course,
close.
He also mentioned, I'm still talking. He
Yeah.
also mentioned the Rayleigh criterion, which is that 1.22 times the wavelength of light divided by the diameter of the aperture, and that'll give you the diffractive limit. I mean, that'll give you the Rayleigh criterion. And
Zach,
where you can discern something, like being able to read a newspaper, or the diffractive limit, be able to read a newspaper print, and how far you could back it. Hold on, you could back it into that and determine the angular size of that particular character on the newspaper, and it has to be a 12-meter diameter aperture to do that, and that's actually right too.
Zanick,
he said, of course, he said it's hijacked. No, it's not.
Oh my
Zanick,
God.
why are you so Zanick? Why are you so triggered? So Zanick, listen, I missed part of what you said because I had a quick phone call and I just cut them off the line because I wanted to continue. But is there what's the big difference between the 0.001? I mean,
where the number comes from? Where the number comes from?
Oh, so you're saying he's telling us it came from the wrong place?
Exactly. He got a value that came from something completely different.
Can you? Okay, hold on. Can you reiterate where he's saying it's coming from, and then where you say it comes from?
Where he said it comes from made no sense to me. What I told you it came from is what it comes from.
You can't reiterate what he said then, where
I can't remember it. It was gibberish. I mean, I probably.
So you don't really know if he's right or not.
No, I do. I knew it was wrong because I know the way he said it was wrong.
The way he said it was wrong.
I can't
So he
put it
didn't.
together again.
He didn't say it right.
Sense.
He didn't say it Zanick way.
No, he didn't use the right values to get his number. That's why he got. That's why he got. That's why. Listen to me, Scalpel. That's why he got 1.2219 something, not 1.219. He got a different number because he got it from different spots.
How much does .001?
He's not off by much, but he got it from the wrong spot. He backed into it from a different.
I'm just curious when this .001 comes into effect to make the difference of
it's not a matter of
breaking the problem.
Scalpel, you're understanding. It's not a matter of
I understand.
how accurate it is. It matters how he understands it. And he said what Bev read, he said was a hijacking of his equation, which was made up. And that's wrong. Bev gave the right one. He's wrong. Bev's correct.
Help me understand how he's wrong and how you're right. Like what the difference is. So I can know. So I can when he says it, I can know in my mind, all right, he's wrong because Zanick explained
ask him again where 1.22 comes from, and he'll tell you.
Okay, where did 1.22 come from? Flat Earth data.
No, that was the question we were asking Zanick.
Yeah,
don't do that one.
And I said it was a bezel.
Yeah, that's right.
He nearly did a Jedi mind trick on you there, didn't you? You nearly fell into that one.
You almost pulled your magic on me, Zanick. I almost fell for it.
I didn't describe it as well as the paper he pulled up on the internet described it perfectly.
No, that was Rodney. Rodney posted that.
Zanick, to be fair, you're saying that he's wrong, so you should be able to explain to me. Okay, so you should be able to explain to me in detail.
Because the number came up with whatever values he used, and I don't remember what they were, they come up with 1.226 something, whatever he said, which is not the right answer.
No, I thought we're talking. Wait a second.
It doesn't matter if they're not. It doesn't matter whether they're
Hold on. I thought we're talking about the difference between 1.219 and 1.22.
because you're not you don't understand even your own
Oh,
question.
but no, wait. Is this the difference between 1.22 and 1.219? Is that right?
No, he said, I'm arguing the fact that he said it was hijacked of his equation. And number
Well, no,
two,
you-
he came up with the wrong. I'm still talking. He came up with the wrong
Yeah,
value, which shows that his values, his equations were
Right.
incorrect. Because if
But
they were
that's
correct,
what
it's
I'm-
the right number. It's not
Okay,
1.22.
Zach,
It's one
Zach.
accurately. It's 1.219.
Okay, so it is. So you are arguing about a 0.001 difference.
Are you fucking stupid? Come on. I said no. It's not about the number. It's about
Well,
where
you
he got
did
the number
say.
from.
Well, you did say you were concerned about him getting the wrong number.
The wrong number. Yes, not because of the error of the number.
So the difference between the right number.
Why he got the.
Hold on.
You know what I said? If I said this this diffractive limit comes from me dividing how many peaches in my refrigerator with the number of apricots on the tree, and I might get the right number. That's
Wait,
why
hold
I'm
on.
arguing.
Hold on, Zanick. But you're saying, just to be
I
clear,
got apricots on my
there's a
tree divided by
point-
oranges in my refrigerator, and I got 1.22.
For fuck's
Am I
sake,
correct?
we're
Am I
not
correct?
talking
No.
about peaches or apricots. Just why won't you let me get this question out and get an answer to it? Ultimately, you're saying, though, there is a 0.001 difference between the correct number and the not correct number.
No.
No?
The average.
So, hold on.
Wait, hold on.
difference
I'm
according to
making up a story. Shut up. Listen.
Oh my God, that's all you guys do is make up stories.
The average weight of, I don't know what.
I've muted Chikey because that was
Thank
for
you.
Zanick.
Yeah, so Zanick, would it be accurate to say that the difference between the right number and the wrong number is 0.001? Yes or no? It's simple.
No, that's not the argument at all.
So you're not concerned about it being the wrong number then?
No.
Because you did say that initially. Unless I'm hearing
No, you
things.
weren't listening. I'm concerned at where that number was derived from. His description of where that number came from was incorrect. Period.
Okay, so to be clear, the only concern you have is where he came up with the number.
You finally get it after all this.
Okay.
time.
Which you
Yes.
can't restate.
Bro, I'm getting to that. I'm getting to that. Where did he come up? How did he come up with the 1.22?
He said something about, he said a bunch of nonsense. And what I do remember is that he said the angle that your eye sees something divided by an arc radian times 360 divided by something else gets me 1.22 something to 96525. And that's incorrect. That's not how you get the number. That has to do with the diffractive limit. The diffractive limit specifically is the 1.2. I'm still talking. I'm still talking. I'm still. Go ahead.
He never said it came that way. He just said this. So
He said,
here's the problem. Okay, but
I'll be quiet. You can say.
No, but listen, it's great that you can say that you don't remember. I appreciate your honesty in this particular moment in time. But if you can't remember and you don't know and you can't verbalize what the fuck he said, how do you know what's wrong?
If I said your name was Joe Blow, the big Eskimo, and you didn't remember that, you would know I didn't say your name, but I said something else. That's good enough, right? I know he said the wrong answer.
The problem
I don't know
is,
what he said because it was so it was gibberish. He
Here's
rattled
the
off a bunch of numbers and it was wrong.
Here's the big problem, Zanick. You think it's wrong for you, but I'm sitting here saying, Zanick, can you please help me? Show me where flat Earth data is wrong so I don't fall into the flat Earth data trap on this particular situation. But you can't do that for me.
Well, I can't. If anyone says the diffractive limit is due to the angle of your eye, then you know they start off that way. That's what he didn't start with. You know, whatever comes after that's going to be wrong. There's no angle of your eye that determines the diffractive limit.
Still waiting for that DM, Zanick.
That's the truth. That's all I do remember. And that's wrong.
Okay. So how do you come up with the 1.22 in layman's terms?
It's the lens equation. Has to do with the focal length.
That doesn't explain it. I was going through this with you before.
No, Bev gave it. You probably weren't paying attention, but Bev read a great description of where the 1.22 came from.
I missed it.
and it has to do with the lens equation, the bezel function.
So I should go to Bev for my information, not
Bev
you.
found the information on the
It
web.
was no. Rodney posted something and said, "This sounds a bit like what Flat Earth Data is saying."
It was close.
Oh, so,
yeah.
it is Flat Earth Data that was right after.
I think so. Yeah, that's what Zanick's sort of saying in a way.
Angle of his eye, blah blah blah. No,
well, if whatever Bev said agrees with what Flat Earth Data
no,
said,
the number in the end was
maybe I could just, when you get Flat Earth Data, explain
you
to
want to learn
me.
or you want to just regurgitate bad information?
Well, I'm just saying.
What's the point of all this? What's the point of all this anyway?
Hold on. So the
He said
point
it was
is,
hijacking. Flat Earth Data already said it. Hey, look, he said it from his horse's mouth. He said he heard it. He said that's a hijacking of what I told you. That's what he said.
no, but my point is I'm trying to get more detail, and you just said you agreed with what Bev said, and Bev just reiterated that. Well, yeah, that was what Flat Earth Data said. So
no, but he wasn't. I already told you why.
Hold on, I'm not done. You're not giving me any answers, so I can just, once you leave and stop rumpusing, I can just go talk to Flat Earth Data to help straighten me out, right?
Yeah, maybe go have some dinner. I'm thinking Mexican for you, Zan.
Or Kentucky Fried Chicken, maybe?
Well,
the answer or
done.
not?
I'm fed up with Zanick's bullshit, so he's done.
If you understand what the bezel.
He's just like that.
Fed up with him.
Bye, Zanick. I love you, Zanick, if you can still hear me.
He's not said actually anything. I'm like, I get it. I get it for a bit where you sort of have these little arguments and stuff, and people want to practice. I mean, everybody has to practice. It's like Zanick's one of the first punching bags that you come across. But it's just obfuscation, right? There's never anything tangible that comes out of his mouth. It's just all
constructive.
Yeah, it's
nothing
just
constructive.
Very seldom do you ever get a great answer at the end of the conversation.
You never get any sort of an answer ever.
Oh, you'll get an answer, all right. You'll definitely get an answer. Oh, that's funny.